Hello everybody, welcome. Welcome to another stream, happy sound day. So, last stream was pretty dope. Yeah, so for some reason when I build the game, sometimes the mouse input gets some data and it just... Anyway. We upped our number of... So each one of these is a volume instance and it's 128 cubed of spheres. So we've got about... Because they're a sphere itself, they're probably taking about 1.6 million, or let's say 1.5 million each of spheres. What we're trying to do right now is try and make this performant and then increase the number of spheres, right? And I want to try and have 1,000 instances on screen, so which puts about 1 billion spheres that you have to try and not draw, basically, right? How you draw 1 million spheres is you don't. So what I want to do, probably start off with today, is I want to get the camera to be fixed up here when we boot it up, so I don't have to keep doing this every time, because I notice we do that all the time. But here we're looking about, well, it was about 5 milliseconds a second ago, and it just went up to 7 or 8. Yeah, okay. Yeah, there's some... Yeah, so it's about 7 milliseconds there. But there's a bunch of little tweaks we've got here, like we can change the LOD. But you'll notice how it's very obvious when you change between the LOD because it gets brighter, right? So we want to fix that today, because the higher we put this number, the better performance will be. So this is basically selecting the clusters cluster's level of detail based on the pixel height or how big it is in pixels. So we want to work on this today where we can improve. Well, basically we can move the camera and see if we get any pop in, right? But we can't do that too well because we get all these effects from the occlusion buffer, which you're seeing in the background, that pink texture with a blue on it. That's the occlusion buffer. We say we reproject the depth from the previous frame, but we don't actually do. We just take a direct copy of the depth buffer. So what's happening is when we move backwards, we end up getting this effect because it's basically culling spheres because the depth buffer from the previous frame is being used as the occlusion buffer. So we need to basically get it to know, like, hey, we've moved the camera back, so move the depth value back by that distance, which is where the reprojection comes in. So I think I want to start off with those two things. And then afterwards, we'll get into something I wrote up on my Discord. Basically talking about how I want to increase performance in the discussion channel. Yeah, so here we'll read over this and talk about how big we want our tiles and how big we want our spheres and stuff like that, and go over that. So let's start off by just hard coding that camera, getting it to a good place. So I just got to tweak some of these things. So why don't we move the position? So the position needs to be probably... Okay, what happens if I don't change anything? What happens if I put it back to 0? Where's it looking? See, I don't know why I was sort of like... Yeah, see, I don't know if the... Let's get rid of this mouse rotation stuff. Okay, damn it. It's just getting a bit of garbage through the... See, I don't know why it gets... When it boots up on the first frame, it's getting some relative... Oh, of course it would do. We're initializing it as 0, aren't we? Right. Maybe we can fix that. So in the OS Linux backend, and probably the Windows one as well, we've got a bit of a problem. So we've got this sort of mouse moved. We pass in, oh, that's the relative position there. So that's for the raw mouse input, but for the virtual mouse, it just does the mouse position. I wonder, because that's going to be right. We could say if it's like negative, don't worry about setting, we could initialize it to a negative value, and then say if it's negative, make the relative mouse position 0, right? And that could be a way around it. Enter notify, set position here so that relative will be 0. Huh. So why are we getting on the first frame? Why does that end up getting movement? We're already kind of doing it. So we could debug this. Let's just do some quick prints. Enter notify. And then we want to do probably the mouse move event. Motion. Okay, so if we in the main, well, not even in the main, just in render frame, we can just do that. Yeah, at the top here. Yeah, just put an exit. So now we should just be able to see some stuff in the terminal. Right, so we want to enter notify, then a motion notify. So why? Like what are these things? Are they floating point? I forget these things. No, it's just okay. I guess it should be D because they're signed. XE, Xmotion. When you build the game, what sort of values do you get there? Right, 640, 480. So that's like in the middle of something. What do we set our position to? This X crossing thing. Okay. 641 and 478. So it's off by 2 pixels, so moved by 2. Right, that's. I guess I accidentally nudged it then. When does I move it there? Ah. Right, enter notify is there. In the motion. Right, is that because I enabled the, by default I enable the trap mouse thing? I got like a trap mouse function, and maybe that's what's doing it. No, trap mouse. Mouse. Alright, there's a mouse hide here. So I wonder if I do that, if I don't hide it, what happens? If I move the mouse here or something, do we get the same thing? Right, we don't get the motion notify on the first frame. That's interesting. So what do we do when we sort of hide the mouse? Ah, I warped the pointer. Whoops. That's been the problem the whole time. So because I warped the pointer, I need to actually manually set here mouse virtual mouse position equal to center position, and then that'll be it, right? So that'll fix the problem where it's moving the camera on the first frame. Okay, that's good. I like that. Good fix. So now when we do this hide, it's not going to introduce a motion thing. Where's the... I just didn't undo those prints, did I? Okay, so we now move the mouse. What? Alright, so just put the mouse here or something. Sweet. It was non-center and we're now... Okay, so now the camera's not going to be moved around randomly. We can now sort of orientate it into the right place with hard-coded values, which is super cool. So I commented out these things as well because that was happening. Wait, those were commented out. We could just test it quick again. Shoot. Right, let's bring these back. Render frames, put an exit in there again. And right, so in the motion notify, we could put a breakpoint. And we can follow this through. Let's just open up in GF and run that. So what we should be getting is, yeah, the position center of the screen. And if we look at GOS, the problem is that damn, right, it got updated from the enter notify. So we would have warped the cursor and the enter notifiers came in. And that changes the... Right, as this going on, so we build up the game and we say hide the mouse, but the game has already opened up the window. So then it sends a enter notify event to the application. Then we say hide, right? And then so and then we poll the events here. Okay. So when we say hide the cursor, we set this to the center position, but then the enter notifier gets, and it will update it here to an old value. We could say if the mouse is hidden, don't bother doing this. I think that's fine. So where do we save the mouse is hidden again? That's in the higher abstraction, isn't it? Or is that in the... Oh, it's over here. Maybe it's not. Hide. Ah, there's a flag. Excellent, this is what we want. So, I guess what we'll do is in the enter notify, if we just simply say if the mouse is not hidden, then we'll update the position. No, we'll just do the whole thing like that. Yeah. Rightio. Should be good. So let's delete that. Exit so it runs. And what else did I want to change? It should be it. Okay, so let's give it a run now. So the camera shouldn't move. Let's go to that view from world thing. Yeah, so these are in, so we've got the relative mouse position. And here we go. Excellent. Able to move around. Sweet. So now I want to orientate the camera so it's sort of like in a fixed position. So when we're looking at numbers, we can tell if numbers gone up or down. So let's close a lot of these things that we don't need open. Okay, so these are the numbers we need to move. So we could probably have so those balls that we display. I need to delete some of this code, man. There's some dead code in here that needs to be gone. I think from like 50 episodes ago. Because we replaced it with a new LOD system now. There's like an X and a Y. Here it is. This is it. So we make the volume instances. So here's a number of instances along the X. We probably want to offset this by this sort of number of instances, and then probably scale by 64. Right. That should move them across. Almost, we're already looking down through one of them. So I guess we'll then probably minus another 32. Or plus, okay. Add. Right, so we're there, that's good. So the x-axis is probably okay. So now I want to move the camera up. So actually go to the view from world now rather than move in all of the models. Where the view from world gets made. Here we go. So we're going to now move the camera up. So we increase the y-axis by, let's just do 4 for now. Probably going to have to be more. Alright, that was clearly not enough. But yeah, I guess let's just tilt the camera down first. So we want to rotate around the x-axis, right? To bring that down. So let's do maybe it might be half of pi. Right, that went up, or did it go down? It would be far easier just to watch this smoothly, right? So just multiply it by time. We have a bit of time, right? Got a bit of time. Time in right, it's here. Just to find after. Damn it. Do a bit of T. Let's just smoothly see what goes on there. Oh. Yeah, it's not compiled time constant. What's the problem? Oh. Oh, it's static. Whoops. Shoot. My bad. Dot x equals ts times. So I want to see the way that rotates. Okay, so it did go up. Let's see that again. Just a bit slower. Yeah, it does go up, see? Woo. So, because it goes up, we need a negative value then. And probably pi divided by 4. Rizima, thank you so much for the raid, sir. Appreciate it. Welcome, raiders. How are we doing? How did the stream go? Hi. How did the stream go? You still work? Did you work on that meta programming? I was gonna say metadata for some reason, but yeah, meta programming thing. Minus pi. Right, I think we're looking down good now. We just got to get the camera in the right place. So we bring it up to about 64. Get you one ball up, right? We probably want to be about a few balls, right? So let's do. Yeah, 6 was 1. So yeah, 192. That's probably what we want. 192 up. Kind of looking good, but I kind of want to be more there. So I want to be like there. So how would one do that? So a little bit more down. So maybe 128. And then probably 64 along the Z, if you will. Not that good today, but yesterday was pretty good. No worries. Yeah, you get those good days and bad days. Good days of debugging confusion. Gotcha. Oh! Perfect. It's amazing. So now we're got a default camera in that position that I want to kind of test a lot at the moment. Maybe it could be in a bit of a better place, but this is okay, I think. It's much better than it was before. So yeah, this is good. Where do we want to go next? Yeah, so as in the stream tile, we want to work on reprojection. So we've got a depth buffer from the previous frame. And then we reproject it. Well, we don't reproject it yet. This is what we want to do. But we use it as the depth buffer. Sorry, nah. We take the depth buffer from the previous frame and we basically just copy it to the occlusion buffer, right? And if you turn it off, you notice how we run out of room to render things because it helps us not render the things behind. But the problem is when you move the camera away. What's happening is the occlusion buffer has a depth value of a certain value in there. and the spheres are small enough, so if we move back, it will think they're behind the occlusion, and they're occluded. So what we need to do is we need to do the reprojection in a more proper way. Yeah, we just need to do basic reprojection. We don't do any at all. There is another. Right, the fans on my GPU are kicking up. Turn that off. But yeah, we should do a basic version of reprojection. So let's actually go to the reproject shader. So this is just doing basically a mem copy, if you will. It loads from the previous one, the previous frame's depth buffer, and then it copies it into the occlusion buffer. So what we want to do now is do the reprojection bit. So let's do some drawing. I'm gonna rest for a while. I'm totally busted. Have a good time. No worries. Have a good rest. I get you. You've had some negative experiences with C. Oh. Well, like. Hey there, Nepal. How's it going? Right. So you got your. This is your view. This frame, right? But when you move the camera, maybe you're moving it quite fast. Like, this would be really fast. But let's just, within one frame, you've moved to there, right? What reprojection does, so here's your ray going from the new, let's do it as a different color. So your ray goes through and you hit this pixel here. Wait. Hang on a minute. Yeah, we need to be going from the previous frame to the new frame. Yeah. So what you have is a depth buffer from the previous frame. Here's the previous frame. This is the buffer. And you have a sphere which sits to a different color. Good old purple. Your sphere sits here, for instance. And you have your ray which goes. That's kind of bent. Let's get a nice straight line. So you have a pixel on your depth buffer from the previous frame, and it is here, right? So what we need to do is we need to make it so this depth value goes from here to here, right? And if you think about where that is in relation, where it is on the previous buffer, it would actually be over here, about here, right? Like this value here. So it's moved from that pixel to that pixel, but to the new occlusion buffer instead of the depth buffer, right? So how do you sort of do that calculation? So you need two matrices, right? You need the old view from world, so how you can get from a view space position. Yes, you need to take your screen pixel, project it out into view space here, or yeah, project it out. Read in the depth value from the old buffer, the old depth buffer. Get your pixel in view space, and then you need to move it into world space, and then you need to move with the old view from world, and then move it into the new view space, and then you can project it back onto this point here, and then write the pixel back. Now you could make a matrix which basically does it quicker. So you could produce a matrix which just does one translation where it's like old view, or like maybe view from old view. So you can just do it in one matrix multiply, or one you could have this pre-computed matrix and then do one multiply with a vector against it. But the problem with that is if you want to do any prediction, which we're gonna probably want to do in the future, where if this object is moving different to the camera, well, okay, if this object is moving at all, I'm in a tick. If it's moving in any way, then you probably want to store like a motion vector so you can predict where the pixel is moving to, and that will be much better, basically. So let's just code up what have we just gone over here, and then we can see if there's any improvements we can make to it. Well, not the language itself, but one class I took in college. Oh, okay. Yeah, I've never had a good experience with learning at colleges or going to uni or anything. So, yeah. Yeah, C is like, C allows you to have a lot of control. And you have to really just learn learn some techniques on how to I don't know, not get too yeah, you have to learn some techniques not to get too I don't know. It's hard to really speak for me now because I've been programming for like 15 years now. So it's hard for me to remember 15 years ago what really helped, I guess. Yeah, there's a lot of like techniques I guess you have to learn. Like I guess I can send you to a resource. This would be a good one. So custom memory allocators. And this will, if you've done malloc and free, right? And you get a lot of malloc and free code, memory allocation. So if you're into the sort of learning like the low level stuff, this helps you get rid of malloc and free and replace it with a custom memory allocator. And it's actually like far simpler than you would expect. All you need to probably read is the first couple to get the idea, and the rest are more advanced. And you don't always need these ones, but just the first couple are good enough. Highly recommend this article, basically. It's really good. So if you're into sort of the low level stuff and want to understand how to write it better, I guess this is a good place to start. Right, so in our global buffer, I think we have our well, I don't think I know this, right? We have our view from world, but we don't have the old view from world. World from view. So we need to be able to go from the old view space to the world space. And I guess we could just keep the transpose of that as well, just in case it might be useful. So let's get these guys populated. So CPU side, we produce a view from world. It's basically our camera, right? So this is in our global. Oh, I'm looking around this file and I realize this is my shader file. Right. So what we want to do is before we mutate this thing, so we mutate it here. We can get transform 3D. I'm going to call it old view from world, and that's just ggfx view from world. So this is persistent in memory, and we basically just update it here. So here's the old one, and all we want to do is just in here, produce, or just put it in the global structure that's accessible to every shader. So now I've got those two matrices in there. We can do the maths that we want, that we just spoke about. So reproject. Still got the depth texture from the previous frame. We're going to take that depth value, and we're now going to produce. So we've got to get our screen. We've got get our screen pixel, and produce a near clip plane pixel, right? So let's find where we do it the other way around, and we'll obviously do it the other way around. Yes, we need to turn it into some normalized coordinates somewhere. Where is it? Oh yeah, projector screen space. Right. It's right in front of my face. So let's take this, and we're going to go ahead and... Hey, Egotist. Yeah, man, doing good, thank you. How you doing? How's things going? So we divided by the Z. Yeah, that comes later. So we invert it the other way around. So screen half dims. So we need to divide by screen half dims. Oh, what did I just do? So we take our screen pixel. What type is this again? Is this... Right, it's float. Yeah, we'll do floating point. So screen screen position, or screen, or pause screen space. So that'll just be SV dispatch index XY. And then we want to convert that into near clip space. So we need to first divide this by, so near clip. So we need to divide by that global. Oh, no, sorry, that's an add. Whoops. Yeah, I think we need to divide by the height or something like that. Yeah, because you want to get it from 0 to 1. I think. Well, no. Yeah. So you got your... That's where your camera is. You got your pixel in screen space. You need to get... this thing has a height, which is also the same as that. Wait. Sorry, ignore that. This thing has a height in screen space. So here's your texture. You have height in screen space, and we want to get the size of a single pixel. Yeah, we just need to divide. We need to divide it so that it is a value from -1 to 1 across the x and y axis, and our origin will be the center of the image instead of the lower left of the image. So we need to divide it by I think we need to divide it by the half height, I think, and then offset it to the middle. So it's kind of the opposite. It's the opposite of this. So we need to subtract at some point. So this, instead of multiply, we divide by this, but so pixel size. Um, let's take some of this. Right, what do we need to do? So that's just going to inverse it. So I guess it's just going to be a multiply. Multiply by this, pixel size, and near clip plane. That brings it down to the right size, and we've got to do a subtract using this half dims. So I think that's what we want. Yeah, so this calculates the near clip plane distance from here in near clip space. Distance from there to there, which is also the same as the height of the texture in near clip space. That's all that is doing. And then we take that and divide it by the height in pixels, and that's how we go from, that's how we know how big a pixel size is in the near clip plane distance. And then we can use that to shrink down there, and then move it, then move our position that used to be relative from here to now be relative from here by doing the subtract by the half dims. So now we've got this position in near clip space. We now need to just move it out into the view, project it into view space. So just multiply by the depth value. So position in old view space. So that is simply, that's a vector 3 this time, make it 3D. So that would be near clip space.x multiplied by depth, position near clip space by depth, and then it'll be depth as the z component. Or will it? Actually, this might be wrong. This will be if you did like rasterization. This would be the way you did it. But because we're doing ray tracing in our depth buffer, we're storing the depth along a ray. What we actually need to do is reconstruct the ray and push it along the ray instead. Is that correct? Or maybe it's going to be the same thing. Maybe it's the same thing, because what you're making here is essentially, imagine you've got this pixel here. You've essentially just made that ray, right? You've got I'm just multiplying it by the depth and taking it out. So you can treat this as some kind of like, it's very similar. Maybe it's the same. Now you go and grab that. So something's a little bit off with these ray directions that we've been doing as well. We haven't been offsetting the UV. By 0.5 of a pixel is something we need to be doing. Right, let's move this here. So field of view and the coordinate being this guy. So with the ray direction, it's probably a very similar it's a very similar calculation, but doesn't normalize. Which is probably which is more correct because we saw the depth along the ray in the depth texture. So yeah, this would be better. So instead, so your position in old view space will actually be instead along the ray direction and by depth. Right. Yeah, okay. That's also more concise too. Right, so with this position in old view space, I think we'll need some of this actually. We now want to translate it into into world space. So world space. So multiply the position, and the position we're multiplying is this one. Wait a minute. What comes first is the transform. So that is old view from old world from view. So we're going to world from view, so we're passing the view thing on the right. Excellent. So now we're in world space. Now we need to move into new view space. There is a way to get a there's one called a project to a function called project. Reproject screen or something like this. Project to screen. I'll find it. It's in here. We saw it a second ago. Right, project to screen space from view space position. Excellent. See, I feel like I'm just making redundant values all the time. These could all just be pre-calculated in the globals. I'll just read them out. But yes, we calculate our size and eclipse plane, pass that in, and then we project it back into screen space. Here's our new screen space position. So position Wait, we need to enter the view space one, isn't it? So we're going into new view space from world. And that is a correct position view space now. That goes into here. And we project that into screen space. Excellent. So now we should be able to put that into the occlusion texture. So if the camera doesn't move, this would be the same as this here, this dispatch index, right? Yeah. But if it has moved, it'll be different. But hasn't the depth value got to change? So the new depth value would be it'll probably just be Z, wouldn't it? No, but it's along the ray. That's the way we store it in the depth texture, I think. It'd be along the ray. Depth texture store closest hit depth. Yeah, it's the one that's along the ray. So what we need to do then. So do we have a hit position? So position in view space is the vector that goes all the way out. It's this red line here, right? It goes all the way out from here to there. So since we have that in new view space, so this one here is the old view space. This one here, but the new one is this guy here. So we have a new view space now. So it's the length of that. Yeah. So that's the new depth. Is equal to the length of this. And that's what we encode into the occlusion texture, but that position in screen space is in here. Now something else you have to do is go, well, if you're out of the screen bounds, then don't actually write. So we've done this line now. But maybe we need to reprojection vectors, there we go. Sorry, the motion vectors we might have to do at some point in the future. But yeah, if the position, if any greater than or equal to, I've done this line here before. Yeah, so if this position in screen space is outside of the screen dimensions, then we should not bother processing this pixel any further. Sweet, so that should be the reprojection done, although I do want to have a bit of a think about it regarding, like, do you just write to a single pixel? Because what happens if you've got a bunch of pixels, right? Like, it came from maybe this one here, and what happens if it moved to about wait, that needs to be made rounded down. Yes, what happens if it moved a little bit to there or something, I guess. Like, it's kind of close, all of these guys a bit. So like, do you just write to this piece here? It is closest to there, right? But yeah, I don't know. I want to think about that problem. Yeah, this needs to probably just be rounded. Like, So we need to, so you'll be given a coordinate So you just truncate it basically. I think it'd just be a truncate. Or like a floor. Hey there, Cranston, how's it going? Just got here, but usually when I do a transform like this, say you want to rotate an image, I loop over the exact destinations to write to and interpolate the sources. Yeah, I was thinking that way, but the issue is I've got the depth buffer from the previous frame, right? So I think it's right. Yeah, because if you go over the destination, you'll fit in all the right pic. You're not going to miss a pixel. But the problem is I have the depth buffer from the previous frame. So here's the new frame, and this is the old frame. How do I take this pixel and go out to this depth? Like, it's easy from the old one because you got the depth value for that pixel, right? So you just go out to there. But how do I get out to there? Is that even possible? Because, yeah, I don't think it's possible. This is the issue. If you got an idea though that can fix that problem, please let me know. Because I was thinking about doing it that way, but I couldn't quite think of a way. And also, it seems like you're following pretty well to pick up on this. Right, and there's a bit of a bias as well. Tackle me in there. Oh. Right, so let's give this a go. Hopefully it doesn't crash and burn the GPU. Here we go. Alright, we're still here. So we got a bunch of garbage now. So I guess so it's not clearing the image anymore. So we need to enable the clear. Occlusion buffer clear. So we used to not clear it. So we need to clear it now and then do the reprojection. Because you might not write to all of the pixels. Right, so I don't think it's writing to any of them anymore. Or something's weird going, yeah. Something's slightly wrong with the maths. So it takes the depth buffer from the previous frame. And we write out. I guess we could write out 0 maybe? And just see. Right, part of the issue is we've got so much stuff. Right, so I'm getting kind of like a spotty output, I guess. Like, is it? Hmm. Hey there, Chandu. How's it going? Welcome back. How you been? How you been? Hmm. So I guess we're not doing a one-to-one map. Awesome. Yeah, not too bad, man. Not too bad. Doing pretty good, thank you. I got finished my wardrobe yesterday, so finally finished this wardrobe that I started building 2 weeks ago, and then I didn't build it last week. It's all finished now, so it's good. I accidentally put in a part upside down, so my dad helped me yesterday and flip it back the right way around. If not, I would have had to drill in like a whole bunch of holes. Um, but yeah, so it's good. Yeah, it's a bit big, but it's good. It's good fun. Yeah, the idea with this project is I want it to be something I can use to help. Well, okay, there's many things that this project tackles. One, it's fun to do. Two, it can help with my career because it is similar to what I do as a full time job anyway. Um, and three, maybe in the future, it could be what I transition into doing. I don't know, in some way. Um, but yeah, I think I still got to figure out how large of a scope I want to make this project when we settle on the game idea. Um, but it definitely is going to require more than me to finish it. Because as much as I can do a lot of things, I don't think I'll be able to do them as well as and quickly if I just had if there's more people that helped out with the project, right? So yeah, I think I could do all the programming, but all the other bits is yeah, not so much. Um, but yeah. Um, depth. So then what we can do is we can say if the depth differs, then we have a clear problemo. So I want to probably say, thing is, I'm just gonna get swamped with stuff. You know, we could just double check it, see what the problem is. So you get our coordinate, we get the ray for the pixel, the coordinate. I've still got to like offset this by 0.5. I need to do that. I could probably do that in this function, and it probably just applies everywhere. And before I forget, I should just do this. It's got to go through the center of the pixel. Yeah. I just don't do that yet. Alright. I'm glad that's fixed. So you go for the center of the pixel. Put our move out to the depth. That's the old one in view. The old view space. Old view to world. Okay. Then world into view space. And then it seems pretty sensible. Then project that into screen space. Yeah, it seems pretty legit. Have to think about that. I get more what you want to do. I think you're right. There's no obvious better way to do it. Conceptually, you have a point cloud that just happen to line up with the pixels in the view. Right, yeah. In the old view. You want to project that point cloud in the new view. That's a good way of thinking about it. Generate a depth map that covers the entire... This shows up all the time in computer vision. They will fill in the missing data. There's some technical names escape me, algorithms. Yeah, I think I could do simply just fill in the nearest 2x2, but then it would be incorrect. I could also probably use quad intrinsics maybe, but that will also not do the whole thing. Yeah, briefly thought about it. Like maybe use quad intrinsics to check your neighbor to see if there's any continuity, right? But then only gets a 2x2. There's things you could do. But I wonder why the basic, like, I'm not moving it anywhere. So if a not equal, I think it's n equal, with the coordinate, I guess, dispatch index.xy, then just do some printing. I guess we're just gonna get spammed like crazy with this. Depending on the constraints on the relative transform between two views, missing data can be arbitrarily large, I think. Yeah. That won't be good. Right, clearly getting a lot of watts. So let's print this out so we can figure out like, hey, so it's x and y respectively. Yeah, I might be able to just do something quite easy, I think. I don't know, to fill in that missing data. Alright, let's try that. Alright, these are clearly wrong. Right, the y value just seems to be 0. Oh, sorry, the x... Oh. Yeah, the new one just seems to be 0. All the way. Oh, wait, I'm flooring it. Is that a problem? Should be alright. So I guess we can do the same thing for the, just comment that out, for the view spaces. Yeah, but I guess we can always print out because it's going to be different, that's for sure. Pause view space. And then pause old view space. All right, let's try that out. Oh. Can it be NaN? Yeah, I guess if the depth is equal to is if or something like that. then we don't really want to handle that problem. Wait a minute. Maybe the problem is solvable. If we have the old view space, if we can translate from the new view space to the old view space, no, that wouldn't get you anywhere, would it? That would just get you the... You'll just be getting the same pixel. That's all you'll be doing. Hmm. Yeah. Right, these are looking to be about the same. Oh, they are the same. Yeah, they're about a little bit off. Okay, so given... Why don't we take that, put it in here. Right, so not seeing it change now. So the infinity was the thing that's causing the problem. Oh, okay, that's good, that's good. So we delete that. I think we're okay. So we give it a move now. Oh, that seems to work. Look at that. Oh, there we go. So as we move here, for some reason it messes up. I don't know if that's because of the reprojection though. It might be. Yeah, so I think it is going to create gaps. You can see up here, if you keep your eye on these guys, when we move, these will sort of fizz. And then, so when we move, they're going to fizz. And that is, and when we stop, they stop fizzing. So that's where they're creating holes basically. So we could probably fix that by, yeah, somehow. But at least, I think this might be, all I need to test is moving back a bit, but... Okay. So these are changing LOD, I think. No, it's not changing LOD. It's not, is it? What's that line? No, it's not that. Okay. Yeah, the LOD comes from the back, really. Yeah, I wonder what that is. Okay, so what's the next sort of thing we want to look at? Improving. So at least we can move like this, right? I guess. It's much better than it was now that we do the reprojection. So now we can notice this pop in, basically. So I wonder if we can quickly think about this problem here. We're going to create a bunch of gaps. So if you got this depth value that you read from this pixel and it just moved over there. So from the previous frame it was here, we moved the camera and it just moved here. Do we want to like only apply that to this guy? Or do we want to apply it to all of these guys? in some interpolated, maybe bilinear interpolated way. Does that make any sense? But that's another thing as well, is we haven't, multiple pixels could get a different value. So what you should really end up doing is an atomic min. So something like this, where we get on the occlusion texture at the highest level, or highest resolution MIP, we're going to write the depth value using an atomic min. Cool. So that solves the problem where two pixels get translated to the same place. I guess that could happen if you move the camera back. You're going to get this pixel is going to move that way, and this pixel is going to move that way, maybe. Wait, is that right? I don't think it'll move that much. Maybe if you move back and move the camera, this one can move over to here and this one can move there. They both write to this pixel. Yeah, so that's the thing, right? If this just moved here, you don't want this one to write to these guys. It doesn't make any sense, right? But if it moved over to there, yeah. Or does it make sense? But how would you do like a bilinear? What is your sort of metric, if you will? Like, do you just take the point and say, you maybe say, hey, it is closest to this guy, so I'm going to put it in here. Yeah. Obviously, I'm not sure how you'd write like less of it into another one. Yeah, so I think we can just live without the dust for a bit. It's not getting in the way. Like these glitches aren't coming from that. These are though, where the dust ends up. Yeah. Problem is that dust gets bigger in the. I don't know. Was that dust there before? Let's look into that. Was that dust in the lower MIPS before? Because that gets quite big, and that becomes a problem. So I guess what we can do, we used to just do a straight copy. So that's reprojection on, reprojection off, and we'll write it into the same. Right, so let's turn it off. Okay, so we've still got some of that sort of dust. We're still getting missing things here. But why would we? Why are we getting missing? Like, we're getting it everywhere. It's not really ideal. Like, those rays definitely have rendered stuff, right? It's here. Right, enhance. So it's a bit blurry because it's blurry because the screen tool just sucks. The zoom just sucks. So we'll just do a full screen screenshot and open up in Krita, and we can just dive into it. Thankfully, Krita opens nice and fast now. It's good. They've changed that. So we've got some like speckles here where the depth value just appears to just drop off for some reason. I don't know why that is. So we've definitely got some form of missing spheres here, but and what is that? There's some way to check a pixel that's obviously wrong. So apparently on the edges here, we go through. So it could be to do with the anti-aliasing, maybe? So if we turn off the anti-aliasing, does this go? That's a question. But we can see like this area. Do we see pixels? Problem is the background itself is black. So it's the same shade as a dark end of the yeah, we can see a hole here, right? I don't know if that's because of run that spheres to render though. Yeah, we shouldn't, well, they overlap. We shouldn't be seeing a problem. Let's turn off the anti-aliasing. What comes to my mind is to reproject the point cloud into the new view and use some in-painting, the technical term algorithm. Ooh. I had a lab in uni and did in-painting in total variation, which uses some heat equation, which I have been solving on the GPU as part of my fluid sim stuff. I'll put this in the backlog, nice. Yes, take a look at that, I've never heard of that. Right, so damaged parts are filled in, nice. So yeah, I guess we can do a full screen pass over. But I wonder, so you're saying it's like an in-painting via total variation. Right, so I guess you'll, yeah. I think that sounds kind of obvious, right? If you just do, I'm guessing at least based on it, if you just have like a full screen pass, you could probably just do a sample of the neighbors, and if one is missing, like you could probably do it in a 9 by 9, quite obviously. If this one's missing, just do some bilinear interpolation of those guys and fill it in, I guess. I guess, but yeah, maybe it's not what that is. But yeah, but thank you. I'll think about this. Appreciate it. Yeah, there's ways we can fill it in with a full screen pass, that's for sure. But thank you, thank you. Yeah, so could we color the background? If we miss, we could color the background a certain color. That's quite easy to do. Yeah, and if more is missing, fill them in a way that minimizes the slope in the filled region. Right. Yeah. Okay, I think I get what you're saying. That's awesome. Thank you so much. Uh, so final color. So if we miss, right. Oh, interesting. No, you must hit the sphere, right? Because if you just skim a sphere, it won't put a depth. Like you won't just only skim. There's no way that you're just gonna solely skim. Let's if we fully miss, we'll store like a white pixel. Let's just have a go at that one. No, we're not fully missing there. That's... Huh? What? That was weird. So when I first launched it up... Oh, weird. But yeah, so we're seeing... So it's nothing to do with the depth value then. I guess let's just render the depth value then. But we're seeing like holes here, like you see it in here, they get progressively worse in the lower MIPS. But we're not seeing any whites on the balls. We're seeing them there though. But it's not the matching ones that we're seeing here, all this dust. So let's see the depth value instead. Let's store closest hit depth. So that'd be like an infinity, right? Is inf. So it'd be 1 if it is infinity. So let's make it white. So it'd be black or white basically. We're getting some infinity pixels. It's flickering though. This is not the same sort of... So basically the anti-aliasing. Let's just disable the... We didn't disable the anti-aliasing and test if it got rid of it. That'd have been a simpler thing to do. So we disable that. And turn off. We're getting a lot more... If we turn off the anti-aliasing, we're getting a lot more... holes. And if I turn off... See, this is without the reprojection stuff. As well, we're just copying the depth buffer from the previous frame. There's something weird showing up here as like a hole. There's a hole right there. So the ray tracer for some reason is going... It's not getting the depth value for that pixel. So yeah, just to show again, we've turned off our new fancy reprojection. We're just copying it into the texture. Um, could it be the draw occluders that goes on afterwards? Here it is again. No, it's definitely this reprojection that's causing it. So it causes it to... Right, it's probably because of the bias isn't enough. Yeah, so, whoops, I didn't have a bias in there. Maybe that was not helping. Maybe we need to add a bit of a... If we had a bias of 1, it feels a bit too much, but let's just see it anyway. Right, we're not getting as many... We're not really getting the holes anymore. But from this sort of level, are we seeing dust? You're not really seeing dust show up anymore when we're still. So I guess it was just the bias. It wasn't enough. 1 might be a bit much though, but maybe it's fine. That's great, we're not seeing dust anymore. See, this bias wasn't enough. So we put back the... Well, let's leave it there for a moment. There's a... Let's quickly view this closest depth thing. So we are still seeing some gaps. Let's zoom in on those gaps a bit. So are they disappearing because we've not got enough? We get some slight... I wonder what those are. They could be... Right, so we sort of see it there with the pink behind the camera. But I guess what's happening is the things behind it are getting occluded. The spheres behind it are getting occluded and chucked away. And so... And we're looking directly through the middle of it or something like that. Maybe. Yeah. So I think we're going to fix this problem by just offsetting the spheres a little. I've just not bothered doing that yet because I'm dealing with more important things. But yeah, that's good. So let's re-enable the anti-aliasing. So it's now going to look good again. So that's nice and soft edges now. So yeah, we still get... Oh. Do we not... We've not re-enabled the reprojection stuff that we've just written. Reproject. Alright. So we put this on and we need a depth bias. 1 feels a little bit too much to me. Maybe it... Anyway, we could play around with that value later. I think one's alright though. So now when we move, we get a little bit of... If you look up here, maybe in these ones you'll see more because it's the lower MIP. We get a bit of like fizzing. That happens. That's where, because the reprojection and it ends up creating holes. especially when you move towards, but when you move away, it's not so bad. But we're not seeing any. Well, yeah, we see some glitches there when we get too close because our buffer's too small. But that's okay. We could probably increase the size of the buffer to avoid that glitch. Right. So the next thing I want to do now is actually fix seeing visual pop in. This one's going to be quite fun. So this is because it gets too bright. Like, it gets brighter, right? Because the surface area becomes bigger when the LOD when it becomes a low level of detail, right? The surface area becomes bigger, therefore more of the light sits on the surface. So what we need to do is we need to make them dimmer as the LODs get bigger. Now you're not really going to see it like this, right? This is just because I've played around with these settings. This is the height the cluster has to be or less to select that cluster to be rendered. So you're seeing here per cluster basis where it gets selected, right? It's not the whole volume, it's the clusters within the volume. So we need to do a bit of maths to make the lighting dimmer. And that should help with that. We're not seeing this creep in, right? And that's why we fix the reprojection, so we can do stuff like this and not see occlusion buffer artifacts, right? Because this is kind of a big problem, right? We don't want to see pop in. And if we can fix this, then this means this rendering is more viable, right? And we can make this min height thing bigger and then increase performance, because we'll see less changes in. We won't be able to notice these changes, perhaps. So that'll be cool. But yeah, I'm just going to take a quick break and get a drink, and then we'll sort that out. All right, BRB. Right, welcome back, everybody. So I got myself another Coca-Cola. Let's do this. Oh. So I want to write down what Cranston gave me a tip on. So to fill in the gaps, so since we are reprojecting from the source to the destination image, this will naturally create holes in the destination image. I should create holes in the destination image. E.g. when you sort of move closer. I don't know. Let's just say destination image. Solve this using in painting and look into total variation. Possibly, probably a full screen pass, something like that. Right, that should be enough to jog my memory. So the next thing I want to solve is that LOD thing we just mentioned, right? I would love to make this sort of min pixel height to select a cluster as large as possible. So when we move, so when we select a cluster, it's going to select the biggest one possible and save us some performance. But the problem is it's way too noticeable when you move the camera. These things like just pop in and they're too bright. And as we went over before the break, the lower the LOD, the bigger the surface area is, so the brighter they become. So the way we solve this is we just simply make the lower levels of detail dimmer. How much dimmer? I think we make them half as dim. Right, half as bright, if you will. So it should be quite easy, right? So this is where we do the lighting calculation. Super sophisticated. It's got a fixed light direction coming from kind of down, but kind of down and then a little bit back. So a little bit from the back. And we basically do dot products with the normal of the sphere. So I'm thinking what we probably want to also have chucked in is the LOD. And what we can do is we can say how much do we want to reduce the light, the brightness based on the LOD. So I think we simply just do so maybe we say n.l multiply equal, and we're going to do something like, here we take the max LOD, I forgot how you do this. Data LOD count, right. So what's the number of LODs that we have? Take away this LOD, take away 1. That will get us, so the larger the LOD, the higher the LOD, the higher the detail is, right? So we kind of want it the other way around. So I want to know how many times are we away from the highest level of detail. So we invert that around. And then we want to say for every LOD, we want to go up in the powers of 2, right? So I think, so we just do like a 1 shift left. Oh, that. So that goes up the powers of 2. So we're saying basically on the highest level of detail, it's going to be 1. Yeah, so I'm going to divide actually, I think. On the second highest level of detail, it'll be 2. Third highest would be 4, then 8, then 16. So that should hopefully be the fix to the problem with the so the problem is we don't have the LOD in the sphere. No biggie. We just got to add it in. Let's just add another integer, LOD. So now there's a bunch of old shaders in here. I've got to delete those. Right. So what we do the LOD selection, and we'd say prepare spheres. So we've already selected this cluster. So we've got it has a specific LOD there. So when we create the sphere for it, we've got to say sphere.LOD equal LOD, cluster LOD. Now we want to take that. So we could definitely pack it down and all that, but that's not to worry. We could probably pack in the high bits of the color or something, but oh no, we can't because we have alpha. We support transparent spheres. Right. Yeah, the packing comes later. Like, we'll probably use fixed point for these guys later on. So if we go to where we use this now, so we go back to calc sphere color. So this will just be s.lod, s.lod. So does it here? Is this the sphere ray tracer or something? Get these things. Oh, this is like the old code. Oh, yeah, the BVH one. Right, so that would just dump in 0. Okay, so let's test this out and see what we get. All right, so let's change the LOD and see what we get. So let's progressively. All right, that's really dark. So that's not obviously what I wanted. That's way darker than. It's made it darker rather than lighter, which is not the opposite way around. But I guess we're on the. Just got to tweak some numbers. Just in that divided by 1 and divide by 2. So how about we multiply this by 0.5 and just see how that. Wait. Yeah. So it's made these ones even brighter now, which is not good. Okay, so clearly powers of 2 is not the way to do it. So why don't we not shift it left, and instead let's just use the LOD number and see how that is. Wait, don't take the 1, because if not it will divide by 0. Alright, here we go. Right, still far too dark. Not as dark though. See, part of the issue is, I think, maybe this is not the right thing to do. So maybe give a bit of we could draw it. And kill the game a minute. So the problem is you got a sphere at its lower LOD ones is a 2 by 2 by 2. So it has 2 more in the background. So I guess it's not the best shaped sphere, but anyway. So these are the normals like that. Whatever, right? This is not really a good sphere, damn it. There we go, much better. Right. So for this one, maybe the pixel step is like this much. Yeah. Right, maybe I didn't draw that one. So this one probably gets something like that. 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 You get the point, right? It's such a big... Like, there's so many that are pointing in the direction of the light. Right? So this is going to be way brighter here. This bigger sphere LOD is going to be way brighter. So we could choose to also just say, well, I guess that's what we're kind of doing with this. With this, is we're essentially tilting it more towards. Wait, I'm making them darker, aren't I? Should I be making them brighter instead? The ones that are further away. Oh, no, no, no. I want to make them dimmer. Yeah, I want to make this bigger sphere dimmer. And it's probably got twice as many. It's been made too dim, isn't it? Um. So what should we do? Well, we could change the normal maybe. Another way of doing it. See, the problem is right now. Yeah, just definitely see the LOD change there because it just gets way darker. But it used to get way lighter, which just made it the other way around. Um. That's an interesting shade. Um. So taking the LOD. How many LODs is it? Is it away from the highest level of detail? So this is just saying divide by 1, divide by 2, 3, 4. It ends up being too much still. So maybe we need to do increments of 0.5 starting from 1. So I guess you would do take 1, start off with 1 plus this, divided by or times 0.5. Let's try that. Right, I saw it fade there to a little bit dark. That wasn't that bad. It still needs to be way better, obviously. But it's getting closer. So we move this up now. We're still seeing that darkening coming over. But we're not seeing the spheres. That's alright. So let's maybe try 1, 2, 5. So let's increase this cluster size. Right. It appears to be somewhere about the same shade now, I think. So let's select something like 32 and see how obvious it is. I want it to be 32, that's the aim. Right, so we're definitely seeing the pop in. That ain't good, is it? So let's move it back down to, I don't know, what was it? It was 12 before. We're not really seeing the change there, although we're seeing this really weird dance going on with the spheres. They're probably so small at this point that they're sub-pixel. So uh, 24 is another good number. Maybe maybe you could do them bigger. You just need to get the normal right, perhaps, to simulate how it looked. So you're sort of seeing that change. Still. It's still a little bit too bright. Maybe that's part of the issue. Right, so let's change that min size thing. Yeah, let's make it 32. That's the number I want to aim for. And the reason why I want to aim for this number is because if we go to my Discord, so yeah, so number one, the most important thing we want to make sure that we do is put some music on. Is that we can select low LEDs as big as possible without seeing a difference. As I saw last stream, when the sphere is around 4 pixels tall, we notice a change in LOD. This is because when we decrease the 2 by 2 by 2 spheres to become a single sphere, there's a larger surface area which we've just been over. And it's because it has a larger surface that points to the brighter space. So we've done this right. We need to move the camera, and we've actually reprojected the depth buffer for the occlusion buffer. We've reprojected that now, so fix that problem. But now we need to decrease that intensity. So I want to aim for, wait, not 24 pixels. So a cluster is a 4x4x4 set of spheres, right? So if we say, yeah, it's 32, right? That was wrong, it's 32. So our screen at the moment is divided into screen tiles. Let's find that image. So we've got these screen tiles that we bin our spheres into. So if we're drawing some spheres, they get put into the array of spheres for each of these tiles, and they get sorted back to front or front to back. And you only go over those spheres that you want to render and ray trace against those, rather than all the others. So if we have a height, so these are 16 by 16, these tiles. So if our spheres are roughly 8 pixels at most, unless we go really far zoomed into a particular volume, then this won't be the case. But in general, if the 8 pixels or less, then it means that they will, most of the time, so if they're half the size, most of the time, they could be like completely within a single tile. But worst case, they'll just be over 4 tiles, right? And this will improve performance because you're getting like less less problems where the spheres are just about going over into another tile and only some of the pixels are affecting it or something like that. You get less of those problems and you won't get these problems as much where it goes into even more tiles. So that'd be a good size to sort of stick around, I think. We can change it to 32 by 32 as well if we manage to get it so that our spheres could be 16 pixels or less, but I don't think we can do that. So I think we can try and do 32 pixels until we select a cluster. So it gives us 8 pixel height for a sphere. So that is a little bit too dim apparently, so let's do 0.25 and multiply that by, let's give that a go. Oh, that one weird. Why are we getting gaps now? I had that glitch before. It's interesting. Right, they're appearing a little bit too dark now. So we're seeing it. Let's change that to about 0.2. See, I have a feeling this might be... I wonder how we would get it for different colors and all this stuff. Maybe they're textured. It's still a bit too dark. Wait a minute. Oh, yeah. So let's do 1.66, I guess. Let's try that. Has it become brighter or has it become... Yeah, maybe I'm just seeing the dark edges a bit more prominent. Maybe we should modify the normals of the lower LOD spheres. Perhaps that would be the better approach. Or maybe having them 32 is too big. So if you reduce it down to 16, that will be... That'll be 4 pixels per sphere. then we start seeing all these sort of glitches. These sort of like ring patterns here. So maybe you see less of that when they're a bit bigger. So how could we maybe so maybe we need to not use the surface normal. Maybe we need to produce different normals of our spheres. So here, right, the lower LODs produce these normals, then the higher LOD. Sorry, the higher level of detail spheres, so the smaller ones, produce that sort of normal. Whereas this lower level of detail, so the bigger one, produces these sorts of normals. And they're not going to be producing the same normals, therefore their color is going to be... The color's going to be different. You want this bit to be dark, because these normals would be quite like that, right? So do I need to... Do we do proper like sphere looking normals like this, or if I change these into something else perhaps? Hmm. And then if you do an even lower level of detail, that will do something like that. Something like that, right? So this one would need... Hmm. This is if you need a way to take like a surface normal and make it emulate being the lowest level of detail normal. Or also the highest level of detail normal. Hmm. Maybe you can convert it into... maybe you could... Yeah, maybe you can convert it into like some form of like polar coordinates. See what LOD you're at, then wrap it around and repeat it, and then turn it back into a normal again. Something like that. I wonder if there's a way to... Wonder how heavy that would be. But if you could take a normal... that's interesting. But the problem with that approach is when the spheres get bigger, when you see it, maybe it's okay. It's something to play around with. So I think you want to take the normal. Mm, and maybe produce a... So we could get a hit position on a sphere. And then probably you can... Yeah, maybe we do it based on hit positions. So if you get hit position on a sphere, maybe... So in 2D, is that called like a circle coordinate? Maybe it's still a... Hmm. Is it called polar coordinates? 2D. Well, what's the 3D? Yeah, okay. Polar coordinates. So you can maybe get a hit position and get. So I guess it's called the spherical coordinates. So when I have spherical coordinates, so imagine if you have this guy here, and maybe you say, maybe you measure it as saying, hey, I've gone all the way around here and I've landed there. And then you probably want to just say, like, so you're saying this sphere is twice as big as, or maybe it's the second highest level of detail. So maybe would you say it's the would you say it's the sort of we wouldn't half it. Because say if you did half it, would it be somewhere like there? What is this? It's half of a quarter would be there. Half of a half would be there. Half of 3/4 would be there. So that's kind of like there-ish, so I was right. Yeah, so it'd be like here-ish. Is that the normal that we're looking for? Uh, because the problem is, I guess, is they're kind of like the lower LODs are like they're positioned in different places. So I guess doing something like this won't map. Um, and I guess this could be different depending on the viewing angle, maybe. But I guess you just want something rough. So this will sort of slope inwards. And at this point, you probably just want this one over here. I guess it would be better if they were perfect circles. See if I can draw these a bit better. They're already quite good. Oh, that one was quite good. Right. There we go. So it's something like that's kind of robotic. And it's a bit that's a little bit off there though. Alright. That's kind of what we're looking for. So yeah, maybe. So maybe you say, hey, if I'm within this section, you're not just mapping it to this whole guy here, this quarter of a guy here. Yeah, this is a bit off still. This ain't a good one. Right. better. So if you're within this sort of range, you're going possibly all the way from this to that range of this one. So you want to get, so if you've got that one there, you want that one there. And I guess it's like an interpolation. Maybe. I don't know. It seems like this is more prominent. Like, or this is a larger area. So maybe it won't be. I don't know, that distance there is that distance. So that is another one of those. That is another one of those. And that is another one of those. Yeah, I guess it is about, it might just be with this crude drawing. So perhaps when you get your sort of, this is a polar coordinate in 2D, but 3D we can do it with spherical coordinates perhaps. So this will only be a case for one LOD change, right? The bigger sphere is a lower level of detail. So from the highest level of detail to the second highest, it would be basically taking your spherical coordinate and mapping it to this. In this case, and then mapping it like this quarter to these 3/4, and then this quarter to these 3/4. I don't know how this would look, but I feel like it would fix the problem, at least with the pop in from stuff that's far away. When stuff gets too big, I don't know how it will look. It might look really funny. So maybe there's something to think about as well. But I think this is worth exploring. Just got to figure out the mass for it is all. So, and that's just a mirror of that one, right? And they're all just probably mirrors of each other, right? So it's probably quite easy to work out. It's just a mirror. But how would you do it if you did 2 steps, right? So if you did another, here's your other LOD coming through here, where it's a even higher level of detail. This guy needs to have, wait, is that even a good thing? Yeah, it kind of probably just misses this one. So it's probably like, wait, probably something like that. No, it's much bigger, but the arc was probably fine. I'm going to be a pro at drawing circles by the time I finish this game. Right, that'll be, anyway, that's kind of bad. But, so in this case, what do you want? Do we really want to nest all the way down to sort of what the highest level of detail is and sort of get those normals? Get those good look, emulate the same look type of normals. So you'll be getting effectively, you'll be going through, like this has got to interpolate between going from here to here to here to here, if you will. So go around and there like that, in, back out, and around here like that. Actually, no. Oh yeah, it would. All the way around to here. This dip. There's a dip here. Because it'll marry up with another one like that, which has another dip. So it just joins up like that or something. Hey, it's on a Divine Fox. How's it going? Yeah, I'm not doing bad. Just trying to figure out this pop-in problem. How's things going with you? So right now you can see the pop-in of the spheres, because they're normals. I've tried to solve it with just changing the brightness, and that's not been enough. You can see it sort of changing. So initially I was like, hey, I'll just make them dimmer as the just make them dimmer. I don't know why we're getting smaller LODs here. I put a max here. That's weird. But yeah, so I know why it was doing that. That's fine. Yeah. So we just made them dimmer, but I think it's the normals that are messing them up. So what I'm thinking about doing now is changing the normals of the lower level of details and making them as if they've got a whole bunch of spheres on them, or they're made up of a bunch of spheres from the higher levels of details. So I'm just thinking about the maths behind that, really, how we're going to remap it. Doing pretty good, working on a Lua bytecode compiler in VM. Awesome. Cool. What do you mean by bytecode compiler? You taking the Lua, turn it into... Oh, no, sorry. Oh, you're talking about like a JIT? Like a just-in-time or maybe ahead of time compiler? Or something that takes the Lua source code? That sounds cool, though. Yes, I think this is possible if we move into the spherical coordinates and do it. How would you do it though? So you'd do so you go over 3/4 of a sphere, and then half a sphere, and then you're remapping that space. Right. And then if you did an even lower level of detail, you have two more here. Oh, for crying out loud. You have two more here, and whatever, two more there. You do an even bigger sphere, which covers, and the normals for that would be remapped. Terrible scale, by the way. But that would be remapped across a bunch of halves as well. So it's 3/4 for the first corner piece, plus the halves. Okay, I think I got this. So we just need to be able to remap from. So we've got hit position on a sphere. We need to map that into spherical coordinates, do the remapping, and then turn it back into a hit position, then calculate the normal from that. And I think that should be it. Making a Lua source to compile bytecode. Awesome. Is it just a sort of learn compilers, or have you got another use case for it? Okay. So, um, alright, so how do we get spherical coordinates? And then we need to go back. Not cylindrical. Spherical. Alright, here's our boy. So we've got our position on the sphere. Point in space. Right. From rectangular coordinates to spherical coordinates, it's P. Right. Oh crap. Right. I'm not gonna be able to translate this 100%. Let me like that one's not so bad. But we need to go. Let's do maybe something in some language. Yeah. Okay. This is it. Human human readable maths. Ah. Okay. This is gonna be fun. So we're gonna go to um. two spherical chords. So we've got some sort of position in space, and we want to convert that to spherical coordinates. So it'd be this mass here. I want to build into my 3D engine, but I've never done a bytecode compiler / runtime for a language. I've done simple bytecode for mass expression engine. It's great. Cool. So you didn't sort of learn, because the or like, are you doing it in a different language then? Is it like a language thing? Because the Lua source code, um, I'm sure you know this, right? The Lua source code is like, it's written in like old C, and it's like quite easy to compile on anything, and it's probably quite alright to run on most things. Um, so let's put all these pauses in here. Right, R theta phi. So okay, so when we get these spherical coordinates, we then want to modify those. And do that wrapping logic, which would be quite fun. And then we go from spherical coordinates to turn it back. So that one is quite easy. Oh, shoot. That's tan angle. A tan 2. I think that's a typo. Right, let's... That's it there, innit? Okay, so something like this. So we'll get an X. So these are just very useful to have in the in the in the code base as well. I think we've got to change those other ones too to have this U32. Sorry, float 32 suffix. I think I've got those in the maths library. Hopefully. So we'll return a x, y, and z. So now we get to try this. So we've got to have a function which calculates the sphere normal. So what we need is a hit position on the sphere. But it's got to be relative from. So vector to hit position. So it's got to be in the local space of the sphere. So here we're going to calculate the normal. So if we convert this into spherical coordinates, like that, then, yes, that's just a length operation, I see. Then we take, and then at the end of the day, right, we're returning I guess we're reproducing that from spherical coordinates, vector hit position, and then we are returning a normalized version of that. So in here we've got to do the logic that we've just been over. You know that Lewis C. LibImagine is prototyped as TypeScript. Oh, interesting. Okay. Fair play. Yeah, I guess you could get a transpiler, right? But yeah, it's also fun writing your own. I wouldn't hold you back on that. But also, so if you've written it in TypeScript, what about just evaluing, like running JavaScript code? Like why have an interpreted language running in another interpreted language? I guess is the question. Seems quite, yeah, seems a bit much, right? Okay, fair play. Yeah, but if you put it into a 3D engine, it seems a bit much though, but still. Yeah, it's cool though to learn about stuff. Um, um, so yeah, the maths works out. We kind of need to know the number of LODs. So what is the LOD that we're getting here? And we need to work out how many, I guess, straight 180s that we want to move. So in the first, if this is so crazy, but okay, so you got your highest LOD here, then the bigger one is the second highest LOD, then this other one is the third highest LOD. So on the first, when you go from the, so the first thing to do, right, is if LOD is equal to 0, we want to do nothing. We want to just return that. I'm not really a fan of branchy code like this, but let's just it in shaders, but well, maybe it's okay. Because we've got a lot of else statement code basically. But maybe it's fine. But if JavaScript engines in the browser or Node are running pretty good nowadays, I guess. But you've still got to manage memory, right? And stuff like that. You just got to manage the GC. Yeah, I think what makes compiled C++ way better is the control over how you can sit stuff next to each other in memory. And you don't have many indirections. Yeah. Now we need to work out how many half spheres you need to move. Half spheres you need to move. So that would be LOD, data LOD, count, take that, take 1. Then you obviously have a... Wait a minute. So on the first one, you're 1/2. On the next one, you got 2. On the one after, you've got 4. No, wait. Words. On the first LOD, on the second highest LOD, you've got 1/2. On the second highest LOD, you've got 3/2. And then you've got, on this one, it would be... Wait, it won't be 3/2. That would have gone in. Right, first LOD would be 0. Is that right? Yeah, it'd be 0, because that'll go into there. This one will give you 2/2 in the middle, and that one. Yeah, so it's something like times 2. This is where drawing it makes it far easier to understand. This code just looks quite alien, I guess, when you read it back. So this will invert around, 0 is handled, so taking 2 is fine. So the second highest LOD would start at 0, and then I go to 1, then 2, then 3. Then we multiply that 0, 1, 2, or 3 by 2. So if this is LOD 1, LOD 2. LOD 1 is going to have a 0, so it'll be times by 2, which would be 0. This LOD 2 will map, or that ends up turning into a 2. We multiply by 2 and you get 2/2 things to do. Excellent. So now we've just got to do the remapping code. So we've got to remap it as if we've got number of 3/4. And this is always going to be a constant of 2. So the plan is to remap a 1/4. Right, let my thing went. Hey VMT, how's it going? Just virtual alloc memory space instead of using malloc all the time. Not quite. Because the problem with virtual alloc is actually quite slow. It's a system call. But you definitely want to do that once, and then you can sub-allocate it. Or you want to do it like a few times. Or as many times as you need, but not just instead of malloc. Like, malloc is... If you run any other program than a basic one, you don't have to use malloc. Yeah, using malloc is sometimes quite easy if you want to write a quick C program. But yeah, we're trying to do something really crazy, VMT. So we've got a bit of pop in. This happens now, and I don't know what I did. Ignore that. But as you see, as the LOD changes, we get a bit of pop in. And originally it was just because the spheres were brighter as the LOD, as we got to a lower level of detail. But as you see, they're darker now. So that's not the problem, per se. They used to be actually brighter. But the problem is they're the normal. The normals just end up making it so you get like, they're just really different. So the larger we have our spheres, although the larger we allow the lower LODs to sort of come in, the normals are just like Jurassic, just different enough. They're just cool. You can see it, and maybe it could be, the art style of the game is you see the pop in, right, and it's just part of the universe and the lore or whatever. I don't know, but I want to see if I can fix this problem. So what I'm trying to do is remap the normal to what it would be if it was the highest level of detail, basically. So we're using some spherical coordinates and trying to cheese our way into some correct normals. Yeah, I don't know if I have. Did I fix that? Maybe that's because I'm not using the lowest. Yeah, I don't know how I fixed that. I don't know what I did. What was it? I'm still seeing some sort of problems here though. But yeah, I don't know what I did. Maybe I can remember it. Yeah, past me did it. I can't ask him anymore. It's stuck. Stuck in time. So do you have fake normals for further away LEDs? Yeah, that's what I'm trying to we're trying to work out now. Yeah, we're trying to sort of remap it. I never quite understood how much the kernel virtual's physical mapping contributes to slowness. Seems like the kernel code needs to basically do the same thing to allocate physical. Basically, the same thing to allocate physical memory. I'm not sure about that part, but basically the kernel doesn't do anything to do with finding you a page until you write to it. So basically, if you have a... Oh, I've already got it here. No. I've got two of them now. When you allocate this, you get this memory back from the operating system. Maybe it's in 4K chunks. Maybe it's 8K of memory. You get this back after it does the syscall and figures out which virtual memory address range to give back to you. But then as soon as you write to it after that, so it's got to do some, it's got some free ranges in the virtual address space it's got to find. And maybe do some memory permission stuff, and maybe probably put this, yeah, like some permission stuff. But as soon as you read or write to this, it's then got to commit the memory. So it's got to find a free, there'll be like an interrupt that happens, and it's got to find this 4K chunk in physical memory, then assigned to that virtual address space. So yeah, typically it's good to do this all at the same time, I've heard. See, if you have, rather than just do it as and when, it's best to sort of, when you allocate your thing, just read the memory with probably the, like, as a volatile read, so it actually doesn't get optimized out, and then get the operating system to like load all of these, assign all these physical memory pages. Yeah. Is the kernel jobs malloc? Is a malloc because it doesn't need to be. Yeah, I'm not sure what the system's like internally, but I can. Yeah, I'm not sure what the permission system's like and other things as well. Um. All right. So how are we doing the remapping then? So we've figured out how many half spheres we've got to remap by, and there's how many 3/4 spheres. Um. So we take our. So let's just do. Imagine we're doing this. Okay. Imagine this is the first quarter in the sphere, like this one over here. Um. Then you basically mirror the result, if you will. So I think we want to just basically ABS it. So we can keep the sign, ABS, and then, so we do something like that. We keep the sign as a vector. So we sign times 3 this boy here. Then we ABS this thing. Work out the normal. And then we apply the sign over. Is it a copy sign or more like a multiply? So if you have a sphere, you put that in, and you got that out, you're just multiplying it and it'll stay the same. Whereas if they're both negative, so you put that in and got that out, that's a negative x, say if you will. You got that positive x. Yeah, you want it to flip around the other way. Wait, because you would have mirrored it into positive using ABS, put it there, maybe it moves around to here or something like that, and then you want to mirror it back to there. Wait, is that what you want to do? Was that what we do? Um, so that's a negative x. You put it here. Maybe when you do the remapping, you get a normal like that. Or maybe it's not even a normal. Yeah, your position like that, I guess. Your position that's here. Then you. So that's a negative y, negative x. You apply your negative x back. Let's sit here. Is that kind of wrong though? Feels it. No, it's saying I just moved down. Yeah, that's correct. So you just apply the sign with a multiply. So mul with the sign. So now we've just got to do the actual maths here on one of the quarters. Yeah. Yeah, there's just memory. Yeah, you have like stack and heap memory. Yeah. That's what you basically everyone tries to teach you stack and heap memory, but it's just virtual memory. Like there is an old sense of stack and heap in the kernel though. Like with but yeah, it's a bit silly though. It doesn't make any sense. It's just it's not AI generated. It's stored. It's stored. We store like the history of what it makes you made used to make the volume, and it just basically draws the volume in and puts spheres there instead. So we've got a 3D volume of 128 cubes, and we like have brushes that sort of draw boxes or spheres in there, and those get filled with spheres. And that's the way the system works. And it does this once when it boots the game up and makes these volumes. So we've just got one, which is a volume which is filled with a sphere filled with spheres. So that's what we've got for now. Right. Oh damn it, C# programmer. I guess you can have a heap there because they have the dynamic thing, but still nothing to do with operating systems. Yeah, it's not how. Yeah, they basically like put everything on this they as they call the heap. That's where all the dynamic memory allocations go, because they don't have control over custom allocators and that. I guess if you marshaled with C code, you could. But yeah. So how are we? What are we doing to these sphere coordinates then? Are we just doing division? Maybe we do like a wrapping. Ooh, like a wrapping something. Wrapping something, the most technical term we've said today. So you've got to map this quarter. So it's actually the other quarter, I guess, because that's the positive edge. But let's just imagine this is positive. Um, you got to map that. This, like, and go over all of these. So I guess you're just multiplying it, right? Multiply by 3/4, multiply by halves, and then you've got to. What are we even doing? See, in spherical coordinates, when you're turning it back into regular coordinates, so the radius goes in x. And then you've got oh shoot. Are these right? Hang on a minute. Okay, so I guess we'll return as okay, so what I want to produce is So pos.x, pos.y, pos.z. We should name that radius. Oh, what did I just do? Cool. Yeah. So I guess we want to move theta and phi, I guess. Because radius you don't want to change. So you're going to take theta and phi, and you probably want to do it, if you just multiply it, it's an angle though. So if we want to do a wrapping add, make a wrap around pi times 2 or something like that. So you probably want to take your sphere coordinates dot y, multiply that by number of half spheres. So that's number of pi's, right? Have I got a pi? I think I've got a pi in the library. That's a half sphere, right? And then a 3/4 sphere is that plus a half pi. Right? Then you need to do that for the z component. And now you need to wrap it in. Now you need to mod it. So I guess you could just use fmod or mod f. I think. Because you don't want it to go. No, but it's sine and cosine. That's probably going to be fine, isn't it? If you go over the edge. Should be right. Alright, so I think that's basically the spherical coordinates. Right, so I think that's the maths. So I think we can calculate the new sphere normal with this lovely thing. So let's give it a go. Where do we calculate the normal? So we have got the ray traced. Problem is, it's done. It's done in the ray trace sphere. Or yeah, this boy. It returns to us a normal. So what I probably want instead is the hit position. So we'll just add yet another set of floats here. Wait, we got a pause. Hit dot pause, we've got it. Already got it. So if we take the hit position, we can use that to calculate the normal. That should be quite good. So here's the tiled ray tracer. Right, so we might ignore. Right, closest hit point. Oh, we already do it here. This is for the anti-aliasing. So we'll do it here. So it's going to be a bit of fun where we say so it's got to be relative from yeah. So calculate sphere normal. Do that and we pass in the LOD, so sphere.LOD. There's our normal now. So let's plug that in. And hopefully we get some shoot. I thought I had pi in my sort of my libc, right? Bit of pi, no pi. Okay, no pi. That's fine. Do my own pi. 3. Let's drop an F on there somewhere. Okay. I think that's right. Pi. So half pi or right, okay, of course it starts on the right or whatever. No, yeah, it starts on the right, yeah. So pi is 180. Perfect. Then half pi. Yeah. Right, so then we got that right. What is depth? Ew, that's a new one. Hit dot T, I think I'll call it here. Yeah. So this actually needs to be recalculated proper up here. So when we do the anti-aliasing, we don't get a T back because the depth is actually different because we missed. So we have to manually calculate it closest hit. Well, here we go. Right, so we're clearly getting some wrong normals here now. So we color it based on the normal. So let's find this. Oh no, we can turn on the color based on the normal. So we can do that. So this is clearly wrong. So I thought it was the highest level of detail. Oh, LOD zeros. Shoot. We want to say if the LOD is equal to take 1. The highest LOD, we do nothing. Right. So the highest level of detail I guess what they should look like. So the problem is that is not really good. So that converts it to 0 to 1 from -1, so... Oh no, I already did it. Oh, for crying out loud. Right, yeah, I already did convert that. So what's the issue with it now? We applied the sign. Done the norm there. Right, I wonder... So we should be... Oh no, this is right. We're seeing like an RGB basically. So red. So blue is there, so that is alright. Guess it's like a green and then still a bit confused. Can't quite get 180. Those colors there are a bit. Right, yeah, this is probably correct. Yeah, it'd probably be better just take an ABS or something. That's why the way we're viewing the color. So instead of we just took an ABS for a moment. This other view is quite alright, I guess. But in this case, I want to just see what it's like. Times 4. Let's try that out. Yes, you're seeing blue this side. You're seeing red this side. Yeah, and then you're seeing green on top. Okay, so the normal is fine here, but it just all goes red, and then already fizzy here. So obviously, the way that we're doing that. So let's slowly try something, right? Let's put that back. So let's do nothing. Let's just do the conversion between the spherical coordinates, then back out into Cartesian coordinates, and then normalize that, and see if we get any. See if it's the same. Right, so it seems to be like the same sort of color. It's fine. The colors are about the same. It's not ridiculously different. The problem is we're getting that pop in, which we're trying to fix, right? Maybe. What is that? That looks weird. Like a cone now. Guess that's problematic. Why is it looking towards me? It's in view space. So we did an ABS. We took the sine and we did an ABS. So if we just returned, if we always returned that, what do we get? Yeah, see, we don't get that sort of cone shape. So is there something wrong with the spherical translating code, if you will? So let's instead just do, let's bring that back. We'll convert two spherical coordinates and then go from spherical coordinates and see if we get that same issue. Yes, and it's changed color. That's pretty cool though. But so I didn't do the ABS here, and then reapply the sign. But we're still getting the problem going from to and from the spherical coordinates. So what is it doing? So that's the radius. That makes sense. We got this from a different website. So no, same one. Oh. I copied the wrong one. What did I copy before? No, it was from a different website, that's why. Yeah. Let's try this one. I think my phi is wrong. So A tan 2 and A. It could be the same sort of thing. I just don't really know the maths. So arc cosine pos z divided by radius. It could be the same maths though. Let's give that a go. Right, we're getting the same sort of color. Yeah, I think it's the same way to express it, just different. So it seems like it's pretty funky though. Um, hmm. So yx a tan 2. I think we could check. Let's double check the spear the output and see if we get the right function calls. Because I'm not sure if I've used these yet. So let's double check that. It doesn't get all inlined in my compiler, does it? Right, we're looking for like an A10. GLSL 450. Yeah, A10 2. You would see that, right? A10. Why isn't it showing up? Probably a whole bunch of square roots. In a square root. Something's clearly off. We should be seeing like GLSL, the extended instructions. as 1. So let's look for 1. It's quite difficult to look for 1. Alright, FMA, we're seeing... Wait, where do I do FMAs? I don't do those much. I guess it's been optimized to do FMAs and all that. Right, there is the optimizer. Let's find the function we're trying to do it in. So the tiled ray tracer. Oh, this is in the HCC code base. No. Right, that explains things. Okay, so we're looking for ATAN. We see ATAN 2 here. And then an arc cosine rate says what? So I think we're compiling out okay. So you see square root. And then there's a division and then an arc cosine. Right, and then it goes back into a couple of cosines. Yeah. And a sine. Yeah, so I think it's compiling out okay, right, using the intrinsics. So that's not to blame. Let's got to figure out why. So when it's pointing near the camera, like that is a 0. Is that a 0 coordinate in some way or something? So if it's in view space and you're drawing a vector towards the camera, so if I shoot a ray, hit that, and I draw a sort of like a vector towards it from the center, in view space, would you call that 0, x, and y? Maybe. Because if you did, I don't know, that changed something. No, oh, I still do these functions on it. Puts those out right, reads these back in okay. Let's double check these functions. Converting spherical coordinates to Cartesian. Right, maybe yeah. The sine. Right, these could be the wrong way around. You might have to flip, you might have to put that sign there because of my coordinate space. So, yeah, I think that's the reason why. Let's try that. Right, we got something different. It's not black anymore. In that spot. Maybe it is. Bit weird, you've still got a bit of a groove though. No, you need to negate the sign, I think. Oh, is that right? I've just... Ugh. It's looking better. You're getting more grooves though. If those were before. But yeah, maybe you have to negate. I'm not sure if that's right. No. Um. Maybe it would be best to say we hard coded it. Like what? Let's say if we did all of them. Like where are we getting that color basically? So what happens if I did 0 and maybe a radius of 50 or something? The sphere, so it's quite big, or maybe yeah, let's do 50, or let's do yeah. So we look at that. They come out this sort of color. So it's not because it's 0 per se. We're calling this correct, right? We're saying from the radio direction. Yeah, then we convert it from view space towards space and use that. Okay. Um. So what would the color be if I took this and just returned it as a, would it be the same color? So if I didn't do the conversion. Yeah, we didn't do the conversion, will it? So it returns purple instead. So I guess it's something to do with the coordinate. Like, I guess if I flip, so if we've got purple, you know, it could be the fact that these are a bit wrong. I'm gonna have to, so that's a pink now. See, we changed that already. Maybe if I flip the axes, we can. It's kind of bluish though, but I'll put that back to that. Bit below. Yeah, so why don't we put it back? Let's just flip the. It is a vector. Yeah, let's just say. Let's just negate that. Wait, that's the right color, isn't it? No, it's kind of more orangey. Kind of loud. Yeah, it's just kind of like pinky. So let's put this back here. Oh no. Right, it needs to be like purple. So let's like flip these guys. Let's just say like y equals negative y. And let's just play around with the configuration of this. Right, so that's the same as just putting a negate down, I guess. On one of those, but we can simplify it in a bit. So let's just negate everything. sure that's not the answer. Okay, so let's just negate x and y. That's the one with the radius though. I doubt it's anything to do with the one with x. Is it? Oh no, sorry, it's the from and not the to. I was getting a bit confused there. Right, it's not the color I want, it's like a dark purple. Let's change the Z. No. I think I've only done all configurations. No. Oh. Wait, there's not many. Hmm. There's not too many. I guess we should print the result back out. Like, what do we get back? Right, so should only just get 50 on the Z. We have 50 on the X. Right. So we might have to just swap the... Interesting. So basically this and this are the wrong way around. Okay. That helps out. So now let's change... So let's just try that out quick. That's not the color that I was looking for though. Oh, because I did the flipping. Right. So let's so we should get purple there, which would be good. Excellent. So let's hard code this 50 into the y-axis then. Let's see what we get there. So we've got 50 in the x. So the x and the... Wait, how do we get 50 in the x? Why is everything going in the x? Because the problem is that the... okay, so because we put the z there. So that y needs to become... I think that's right now. We've got to go back and try the other one. Great, so let's put 50 in the y. Let's put 50 back in the z. And see what happens. Excellent. Right, so just got to try one more. So we'll put 50 in the x and it should stay in the x. No, it's gone in the y. So why that? Probably something to do with the sine and cosine stuff. Right, maybe that. Right, maybe it's this. So before we change anything around, let's get our things straight. I think this sine, like this sine needs to go here. And this cosine needs to go there. And then we might need to swap out x and y. Yeah, I think that's right. So let's start at z again. So z, it now puts it in the y column instead of x when we initially saw that. So we swapped the z and the x initially, but now I think we just need to swap these two. So now this becomes z, this becomes y. Okay, so that's correct now. It shows up 50 here. Let's move the 50 into the y. So we should see it only show up in the y. Great. Now let's move it to the Z. It's a different problem. Sorry, the X, I meant. Move it to the X. Now we've got it in the X and Y. So this should be cosine, probably. But I don't know. Okay, so that works. Let's move the 50 back from the X column to the Y column. Am I disappearing yet? Yes. It's slowly fading away. Now we're seeing nothing. Bum bum bum. Right, so don't do the sines and cosines. Bit problematic. Right. We got an idea though. What's going on? Right. I'm just going to quickly BRB, get another bottle of water, and then we'll. But we're on the right track. I think this is fixable. It's just something to do the coordinate systems is a bit off. But it shouldn't be too hard. Right. Right, so welcome back everybody. So, coordinate systems. So something's wrong with these sine and cosines. It's not reflective of our coordinate system. So let's figure out why. So let's reverse it back to what it was. Yes, that's how it was. So we had a problem with a Z, putting it into the X, is that right? Yeah, putting it into the X column. So that was because this had sine. But then if we make that sine or swap these around, yeah, one of them becomes, then when you turn Y on, this doesn't get anything. So maybe they both need to be sine. No. Right, let's see what's going on. Maybe. And that one's only, See, the problem is, So if I make this one have sine, I don't think that's right, but I'm just going to give it a go and see what the behavior is like because I haven't tried it yet. Right, so that's correct there. We're getting Z gets. Wait, but it's flipping these here, so I'm seeing a bit wrong. Let's try that. Right, that's not getting a good answer. So put it in the Y. We're not getting a 50 in the Y at all. Nothing in the Y. That's because we need a sine on the phi. So you need to put sine on the phi there. Then you no. Because the Z got it when it was cosine. Yeah, this is wrong. It's probably wrong still. But that'll work probably. No, still wrong. Alright, let's put it back. Let's go again. So usually in 2D you just swap these two around. So let's just see how they are when we move them around. So if we put 50 there, oh shoot, where's my print? No, my print. Yeah, let's just print them all, them all out and see where they move to. And if we get overlap, then that's weird, I think. Right, float, float, float. X, Y, and Z. Okay, so from Z it goes into the X. And then from Y it goes into the Z. And then from X it goes into the Z still. Right. So X and Y both go into the Z. Why is that? Because they both... Right, so that's sines phi, and then this sines theta. Um... Mm, um, how could that be wrong? So x and y are ending up in the z column. So it must make x and y at 50 must make phi. We should print out the two. So we'll print out we'll print out theta and phi as well. So let's start off with z. So it's got a sine theta of 0. So that'll get cosine of 1. No, sine of... Yeah, so I must get sine of 1. And I guess we move it there. So that would be... Hang on a minute. Sorry. So it's going to the x column. So if they're both 0, this will probably be 1 times 1 times radius. Then 0 times 1 times radius. 0 times radius. Okay. So for z, okay. So if we put a 50 in here or a 50 in there, so the 50 in the middle one gets you about 1.5 on each. Whereas this just gets you 1.5 on the right hand side one. Okay, we've got some numbers. Let's write them down. So this gets you 0, and that's half pi. So I guess we do pi divided by 2. This gets you pi divided by 2. Pi divided by 2. This gets you... we want to do 50 on it. This gets you 0, 0. So with this, how do we figure out... Yeah, we've got to figure out how do we get 50 into the right place given these inputs now. So pi divided by 2, if you chuck that into sine... Okay, sorry, let's start with 0. 0, if you chuck that into sine, it gets you 0. Chuck into cosine, it gets you 1. Let's write that. Sine 0 gets you 0. Sine cosine 0 gets you 1. Let's do point f's as well. Just to, this gets you pi divided by 2. Let's calculate it just in case. Do some sciences. The pi divided by 2 is 1.5707. Just 7. So if you sine it, it gives you about 0. And then if you 1.57 cosine gets you 1, about 1. Okay, good. So it's the same. So wait a minute. No, that can't be right. What am I doing wrong? Because how could it transfer? Yes, the x and y are both going to the z at the moment. So the x and y are both going into the z at the moment. But how could the pi divide by 2? Like, how could these be the same? Um, um, hmm. That's confusing. So if you put... So we put 50 into the z. These two would both... so the theta and then phi would be those. So phi would be 0, so you would get back 0 here. But then you probably want it to be cosine. At least. Then... But the thing is, it's the same sort of thing though. Like, why? So for y, it's going to get... So this one, you at least want cosine. probably. Maybe this one is then cosine. Is 1 times 1. So for y, to get in the y field, you need y to be to have so basically none of them need sine. Like it's the weirdest thing. Hmm. What about negative? Say we did like a negative one of those. That's the same. It'd be the same thing. If we negate that, it'd be the same thing, wouldn't it? Yeah. It's not it. Hey there, Crescent. You got sine, cosine, or equivalent mixed up on lines 60 and 261. Well, are those mixed up? No, because the sine of that is basically 0, and then the cosine basically 1. Yeah, this is the bit I'm confused about. It's like, so why am I getting... So x and y and I get put into the z column, and then z ends up going into the x. But then I'm just thinking that these are going to make... Yeah, how does that... How does that end up... Yeah, so something's wrong with these. Because how would they end up going into different ones? How do they end up going into different ones? This is strange. I was in degrees mode. Oh shoot, thank you. Picking that up. Damn it. Degrees. Thank you so much. Right, so 1 point. So we sign that. We got a 1. Okay, this makes more sense now. Oh. Right, cosine will be the opposite. Okay. Good. So, right. Let's just double check that. Yeah, basically 0. Cool. So, right, now we should be able to work this out then. So, if you've got z, it has inputs of 0 and 0, which means it needs to, like, this needs to be a cosine of one of these guys. So the only one that has, or both of them, it needs to be cosine of both of them or just one. So this could either just be cosine, or this could be copied here. So for now, okay, so I guess we can just remember that. Then for y, you got both of them as pi over 2. So as sine it will be 1, cosine will be 0. So they either both need to be cosine. They basically both need to be cosine in that case, right? Or just you need one as cosine. Then for the x field, you've got pi divided by 2. So one of these will be 0. And one of these will be 1, basically. So it's just the opposite way around. So theta is 0. And pi divided by 2 is for phi. So if you want this, you've either got to have a sine of that and a cosine of that. So a sine of phi and a cosine of theta. So I was right by moving it there in the past, right? So imagine this would be a cosine. So to get these to be right for y, you want to have a cosine theta and a cosine phi. Is that right? No. You want like the opposite of that. So you want this to be sine and sine perhaps. And then for z, you just want cosine of phi. I think, right? Let's try that out. It's a bit silly though. Right, so you put z and you got z back out. Let's put a y in. Do we get a y back out? And then we'll mix them if we get them all right. Yeah, we have. Put an x in, do we get an x back out? Yes. Okay, that's good. So what happens if we do 2 of them at the same time? So let's do 50 in the x and y. Do we get 50 in the x and y back out? Yes, we do. What about 50 in the y and z? Does that happen? Right, y and z is fine. Let's do 50 in all of them. What do we get? 50 in all of them comes back out. Let's do 50 in the x and z. What do we get? Good. What happens if I negate one of them? And one of them gets negated. Right, this seems good. Thank you there, Cranston, for the help. Appreciate it. I'll probably still be stuck. Wasn't for that help. Appreciate it. So now we've got the correct mapping from spherical coordinates back into Cartesian coordinates, right? So now let's run this and see if the normals are still colored the same. Damn it, I thought oh, there's a print still. Okay, so let's run that. So if we change the LODs, we should still see the same sort of normal color, and we do. That's good. So let's re-enable this. This is the code which remaps, which is what we've been trying to work on. Effectively, we're remapping the normal that we would have got on the highest level of detail, and we're remapping it onto the spheres at the lower levels of detail. So this one would get any of these guys. This one would get any of these guys that keep going on. So it's the one in the highest level of detail gets moved up. So I think we've done the maths all right. So let's give that a go. Wait, did I compile that? So let's change the, oh, that looks a bit funny. Change the LOD. Right, it's bloody noisy. So this is clearly not right. So I think we might have to do some form of like modding maybe. So I'm multiplying. Is that right? Wait, it shouldn't just be addition. That's still wrong, but it's more feasible. So maybe we have to mod it now based on pi or something. Let's just give it a go. So mod f32. And pi, I think. Pi times 2? I think that's right. Okay. It's giving me the same answer, so something wrong with the other code. So the modding is probably not going to help. But we'll leave it there just in case. You can always remove it. So it could be something to do with the sign, but I don't know yet. So we've got let's do this thing again. So the second highest LOD is going to take 1 3/4, 2 of those guys. That's the problem. It needs 2 of them. And then another 3/4. Oh no, sorry. No, that's the second highest LOD. It's this one here. Drawing's a bit weird. I should have done different colors. So it needs 1 3/4, 2 3/4. And it's going to add... What's it doing? It's going to take pi... It's taking pi plus pi times a half. So it's 3/4 of pi times by the number of 3/4 spheres. So there's 2 3/4 spheres. And I'm taking this, so I'm taking this here, and I want to remap it to that. So we should probably also start it off as a by taking away a pi, quarter pi, I think. Yeah, take away a quarter pi. So we first start off by taking away a quarter pi. Pi plus so I'm going to take away a quarter pi. Let's try that out. That could be the fix. Oh, those colors are looking better. They're looking the same sort of shades. Interesting. So we're getting some sort of like wrapping issues now. I don't know, something could still be off. We are doing this mod thing. Mod thing was fun. Okay. Let's keep that there. Well, I don't know. I don't know. Keep commenting it in and out. So I guess we'll just do an F0 around it so it's an easy change. Right, so let's look at this. So we realized that we should have taken away some form of, for that normal we need to take away half a pi. So you go back to there because of this one here you want to start on, right? And then you're saying go. So if you go 1/4 of a sphere, so let's say for this LOD here, which encompasses a 2x2x2 set of spheres with one sphere, we're taking this and we're moving it back a quarter, right? And then we'll go around 3/4 there. And then we're kind of going not round a half, but we're kind of mirrored back out again. So going all the way back up to there, like but if we take my current logic, it sort of goes round here again for another half and puts us back up there. That's wrong. What we want to do is mirror back. So instead, so you've done 1/3, right? Mirror it. Wait. I'm not taking into account. Right, so I need to interpolate along this sort of thing here, if you will. That sort of thing there, based on how much yeah, based on that first quarter. Ooh, that's another thing. You've only got one. I'm gonna do it. This is so too much overdraw here. But yeah, I'm doing 1/4. So I've got one. I should only be dealing with half of the things here. So number of these is that, and it shouldn't be a times 2. That's the first problem. So if we take on normal, and it's here, it needs to be like interpolated, like this. Distance from there to there needs to be remapped to that range. Right, so that's maybe that distance of the whole of that. So let's say half, for instance, right? Let's go there. So that's half of this. So the max possible range of this. So you need to go from here to here. There's half of that, so it gets you there. It's kind of about the same actually in this case. Not a really good example. Maybe we do a quarter. So there's a quarter there. You take a quarter of that. So that's a half. That's a quarter. So your normal needs to go there. So are we doing that correctly? So by taking the so um So it's like a... So we moved our thing back by a half or whatever, by half a pi. Wait, it should have moved back by half a pi, not 3/4 pi. I think this is still wrong though, but let's just do it anyway. Half pi. Still think that's wrong, but so we moved back by half pi, and then like we've got a, I guess, a spherical coordinate now, and that's what this is. Is it some lerping then between something that is so I guess we compute how much we want to rotate around, and then you can sort of do the lerping basically between the two. Well, you could do the remap, but we've got that problem where you got this sort of, I need to draw this better. Let's just do the second highest. Right, so this bigger one is the second highest LOD. The smaller ones are the highest LOD. Let's do it from the proper hand side now, because I did it the wrong way around for some reason. So here's the positive edge. We only calculate from the positive edge. So you've effectively got these 3/4 normals to recalculate. So if you go here, you get a normal like that. If you go in here, you get a normal like that. Go in here, you get a normal like that. And it just keeps going round and round and round and round, remapped like that, right? So effectively you're remapping this to that there. How would you do it? You've got this in spherical coordinate space. So I guess it's in the y and z component. So I've got one quarter sphere to look at. So if it was here, it'd be mirrored. Before we do the calculation, it will be absoluted. So it ends up there. So that solves the mirroring problem, perhaps? Maybe on the first LOD. I think let's just solve it for the first LOD. We'll solve it for the others next. Right, so this is like an absolute that solves that problem. So now it's just a case of doing so you know your value is between this and a quarter pi, right? So 0 and a quarter pi in spherical coordinate space. So you're remapping that to 3/4. So I guess it's just multiplying it by, it's just a multiply. Yeah, so it was multiply, right? You're scaling. You're scaling it by that many. Or maybe the scales were a bit wrong. These might need to be added. So maybe you can call it the scale. I think it's addition. Right. Um. Pi plus half, I don't know. So I think we should just do, you scale them. So we scaled it, then took it away. That might be the answer. Took away half pi, so it'd be a quarter of a sphere. So let's make this a bit easier to read. This is quarter sphere in radians. 3/4 sphere in radians. Okay. That's just pi, which is half sphere, I guess. Okay. Quarter, no. I know it looked funny, thank you. Right, so I think that solves the problem, right? It's just a scale. So if I'm I'm half around, right? If I'm half, no, because this is already in radians. So I need to essentially go. So imagine if I was moving a full way around, I guess that'd be easier. If I was remapping around a full way and I did half of, I'm half along here, and remapping all of that to a whole, that would end up down here. So what am I scaling that by? I'm just scaling that by 3, right? So I think the scale just needs to be the number of quarters, because you've already got it in radians, perhaps. Let me comment this out, and we'll do that again. So I think we need to now So the scale is perhaps, so the number of quarter spheres that we multiplied by so you end up basically somewhere like here. Yeah, so that half will map to sort of this half. Um, so to turn that around before we take away, you'd end up like here basically. And then you take away the water and end up back there anyway. Um, that's just not a time, that's just like a times 2, isn't it? Like, or does the other one be times? Hmm. Like, so say if I only had a half to go, and a remapping to a half, it'll be remapped to here. There'll be times in like 1.5. 3 quarters will be times in by 2. 4 quarters is times by 3. Hmm. Now I'm confused. So it was. Hmm. Yeah, it's definitely much more simpler than I've been writing. So if you take this, which is half the way around this part of the sphere, and say if you want to remap it, remap it to the full sphere, it will go around to there, right? That is, yeah, so how would you do that? Times by 2 will get you to there, times by 3 will get you to there. That's not right. Times by 4 will get you to there. So what is it? Um, so um, this is pi. That's half pi. You're gonna go from half pi to 2 times pi. That'd be increments of 1, 2, 3, 4. Yeah, times, right, okay, times 2, 3, then 4. Okay. So if that's if we're gonna go the 4 way around, 3/4 the way around. I guess it'll just be times by 3 then. It's probably just that simple, isn't it? So I guess it's just this number of 3/4 times 3. A number of halves times 2. I think that's the scale we're looking for. Although this is only for the first LOD, it's not going to solve the second LOD. Yeah, so we're scaling our quarter by that many times. Then we move back by a quarter of a sphere in radians. That solves the problem. So this will get moved to here and then taken back to there. And that makes sense because it's halfway around, and halfway around this sphere is there anyway, right? So that's fine. But if you put it here, that's a half, that's a quarter, right? So there's a quarter. So you're a quarter around here, so you're there. It will multiply you by 3. You do 3/4 of that. It's likely to stick you here-ish, and then move you back half a quarter. Here-ish or whatever, move you back half a quarter and get you to there. Something like that. The maths checks out. So we try that. I need some pie. Let's try that. Oh, there's that glitch. Just ignore that. Okay, so let's make the bigger spheres. Whoa, that looks funky. That's clearly doing it way too much. That's for the highest LOD sphere. Let's do second highest. Did the second highest go okay? So these should have like they're kind of okay. I guess the mirroring isn't helping. Something to do with the they should be it shouldn't be so clear cut on the seam. It does seem like it goes in though on the x-axis but not on the y. It should be smoother, I think. Perhaps the mirroring isn't helping. Yeah, perhaps the mirroring. Do we mirror back? We do, we've got the sine. So if you got this one here, yeah, so if you got that one there, it's gonna put it into positive, and then you'll get this. You'll probably get something like this one, and then it'll mirror it back. You'll get that. That seems correct. Yeah. So you should only be multiplying by 1/3. So you scale by the number of quarters. think that's right. Then the half should be 0. That first LOD. You know what, maybe some of these are looking okay. Like these, I don't know. That's probably what you're looking for. It's angled towards the view space though. You're probably looking at something like this. Like, because all of these different colors are a bunch of spheres. No, it's still wrong. Still very wrong though. Yes, the easiest thing to look at is the second LOD. Second highest LOD. Yeah, we didn't do the wrapping, but just gonna wrap it by 3. Yeah, 2 times pi. It's the same. So shall we remove the mirroring and see what happens there? So the mirroring, let's remove the ABS and let's make the sign be a 1. A 1 vector. Alright, so we're getting here. We're not getting the mirroring anymore. That's interesting. So this could be what we're looking for. Let's go. So this is the second highest level of detail. So the problem is it's looking towards the camera. We're getting something very weird there. We should be seeing 4 spheres in a way. And it should be pinching. Like it should be pinching. So it should be pinching in here. Like we should be getting some normals. Like when you put your 1 here, it should be firing out like that. Right, and then like that and that and that. These sorts of guys. And so if we did that one, it should then be firing out like that. The other way around. Oh, wait. Yeah, I'm trying to squish 3/4 of a sphere. So I'm trying to get the normals. The normals of a. So we've got a sphere-based renderer, and we've got LODs. 2 by 2 by 2 set of spheres become 1 sphere. I'm trying to get the normals from the highest LOD and have them be shown in the second, in this lower level of detail. So it's kind of like remapping 1/4 of a sphere into 3/4 of a sphere. But that's only for this case. In another, when you have more LODs, it gets a bit more involved, I think. But yeah. Let's view our. Let's change the viewing thing and make it do the lighting instead. Right, this is clearly wrong. Yeah, the normal is clearly wrong. It's following the camera. Why is it following the camera? Why is it following the camera? We're transforming it. I don't think that's right. In what direction are you projecting to map between the LOD? Hey there, us must go. Right, so these shown up okay. Yeah, so these ones don't follow the camera. So 2 seconds, I'm just checking something. Why are you following me? Huh? Why won't it turn the camera? I guess you get different normal. Yeah, it's just such a big... Yeah, okay, I know the reason. Right, so what am I trying to do? In what direction are you projecting to match between the LODs? So basically the idea is you've got this lower level LOD which is bigger, right, and it has 4 spheres in it. So I'm thinking, you know what, we can take we can essentially remap this to like the first part of, you know, this quarter to these 3 quarters, if you will. So this one maps to there. This one, which is halfway along, will map to here, right? Because it's halfway along this thing. And in between those two, this one will map in between those to somewhere like here. So remaps the normal, basically. Yeah. So the way I'm currently trying to solve it is I'm trying to solve it just the first level of detail at the moment. So we take the first... Yeah, so we've just got basically... I was trying to deal with the mirrored problem. I was trying to leverage the fact that it is mirrored. That the problem could be mirrored. So if you have a normal that's here, if we make it absolute, it's the same as this one here. But we've got these weird issues around this area. It seems to have been a clear cut, and the normals ended up being obviously different each side. So I don't know why that is. Let me undo that. So I put the ABS back. 2 spherical coordinates. Take the sign. And I guess when you bring it back out, it's not going to be correct. So maybe you can't leverage the mirror. Maybe you can. Yeah, so this was getting some clear. Right, so go to second highest LOD. We're getting these clear sort of cuts. It's fine to be following the camera here because I'm using the view normal. But yeah, we're going sort of 0, 0 all the way to red that way and then blue that way. And then it's green over there. No, and then it's probably a red on the other side. Let's see. So it's better if we display the view. Yeah, it's like a yellow instead. Green. Mapping a bit different. I guess the Y, is the Y mirrored? Already mirrored though. This one, that's mirrored okay on the blue, but that red isn't still. And that X appears to be mirrored there at the start, and then as it goes up there, it's a bit off. Right, so take the number of 3/4 we need to move by, would just be 1 always. We multiply that by 3. We scale the theta and the phi in spherical coordinates. And then we take away quarter sphere in radians. Let's remove that for a moment. Taking away the quarter. Yeah, it definitely seems right. So we're getting 4 repeats when we do it this way. So if I change this number to like 2 instead, let's just see what this looks like. Right, there's 1 across the half. Yeah, I can't see another one in place. Right, so if I didn't do the mirroring technique, what do we get, right? So instead, if I take this quarter, I've got that. So we'll get the spherical coordinates for that. I then add, I do the ×3 thing. Well, let's do the halfway, I guess. Half. So the half is there, so you get this. Then you bring back. So around the outer sphere, you'll get that. Bring back a quarter. Oh, sorry. This, so it'd be halfway around. Yeah. So you're multiplying that. Times it by 3. 1, 2, 3 or something. 3/4. Not there. No, something's off. Something's way off. No, that's the half. Is that right? Yeah, that's the half. So your vector will be there. You'll take away the 1/4 and you'll end up back here. That's perfect. Right, so maybe we don't need, in this case, to do the mirroring. I'm a bit confused now. Maybe we don't need to do the sign trick. Maybe it's fine. Right. Ugh. He kind of pinches here. We're expecting pinching. We're expecting to see 2 pinches, right? We expect to see pinch here, a pinch here. Well, four pinches, right? A pinch there and a pinch there. Expect to see a couple of pinches. Why don't I see any pinches? So let's change it to view a world space normal. So let's do this. World space normal. So in the calculate sphere color, we'll drop that in. You can always comment this out, which would be pretty nice. So now that's moved into world space, we can look at it a bit better. Why am I seeing it move? Wait, it's already in world space. So we passed it in there. So it's already in world space? Why is it moving? I guess it's just the way you've got the direction. Yes, this is the highest level of detail. This one doesn't do the trick, so it doesn't have a problem. Now these have the problem. The ray is not... Maybe I need to do the calculation in world space. Maybe that's part of the problem. So if we move it... So this is the vector. If we move the vector into world space, maybe that helps. Let's try that. Right, so now they don't move because I do it in world space. Okay. So we're not seeing any other. We're not seeing. Wait, are we seeing pinches? Is it pinching? It's gotta. We expect to see something where the normals go like this, then like that, but we're not. So I don't think the technique. Well, we've removed the sign. Let me copy those. Right, let's put the mirroring back. Let's go back to where we calculate the color. Put those back. Oh shoot, it's in the wrong place. Is it? No, it's the right place. Alright. So see these guys now. We'll see the pinching, but it's a bit wrong. Yeah, so it goes... Maybe that's right. Because that goes... So blue is Z, right? And then... Well, we don't know what color it is. We should be doing... Right, this seems like it could be correct. At least just for the first LOD. When we're doing the coloring, we're doing this sort of multiply thing here. Wait. Yeah, but instead we might want to do like an absolute. So here we're going to have two versions. This one is going to be normal equal something like that. Then we can have two options and one which just absolutes it instead. Alright, so two versions we can switch between at the flick of a switch. So with this one, we are seeing that there is a pinch here, right? As it goes to here, the rays are going probably to the right, and then they go to the left here. And there should be another pinch. Why is there another blue ring? We've seen too many blue rings. Yeah, there's a red ring. We should only be seeing 4 pinches from my understanding. One here, one here, one here, where the rays sort of will go same sorts of ways. Sorry, there'll be 4 pinches on each to that axis, and then another ring going this way. You'll see another set in the z-axis on these two as well, near and far. You should be seeing 6 pinches. So it's moving way too fast. But why is it pinching? Right, it'll be pinching all the way around, wouldn't it? Because you get like this sort of... This will tend to be pinching all the way through here as well. So you will create these rings. So you'll get a pinch going up. So I can't see the spheres in here though, the George Charles spheres. I think there's just one too many pinches. Now why are you seeing... No, it should go blue. Imagine if this is Z. It should go Z near the front and then it goes round like that. Yeah. This is right. And you'll see another sort of Z looking one here as well. Yeah, that's correct. That's good. Man, this is complicated. Spherical harmonics. Yeah, I've heard about that stuff. It's a bit over my head at the moment. How are you going to avoid normals pointing away from camera? Right, the ones at the back. Yeah, so we're not going to get those, I don't think. The ones that go through. Maybe. Yeah, I don't think we're going to get those if you have your camera. Maybe when you look directly through it. So we might offset them a bit to cover the middle pieces if this is what you're saying. Yeah, I think that's correct. I would want to try and color in it with the lighting and see how that looks now. This doesn't feel right though. Yeah, maybe. Like you're getting the brightness. Let's change the LODs. Maybe. Where's the 2x2? Also, these 2x2s just feel off to me. Unless, right. I need to find an edge 2x2. That feels a bit off to me. Let's go up to the top. They are a bit darker because I've got a bit of extra maths, which is causing that. I should probably turn that off now since we're doing this. Yeah, let me disable that. I was trying to make it darker the higher the level of detail was. No, my son's not in Hello World yet, unfortunately. Nearly though. Sure, I'm sure it'll be there next week. You know, you have to start them early. How's it going, Sully? Right. This is weird. Okay, I could have swore like something like here gets a 2x2. Like, no, it doesn't. Okay. Yeah, those disappear. That's great. Do you get 2x2 there? They seem to be offset a bit weird. That's interesting. And the pinch feels off. That should be black. No, that's right, because that is the pinch and it goes out to the right hand side. Yeah, that goes boom to the right. This one goes boom to the left, right? So the point is, far away, this should help out. That's the hope. But let's go to another LOD. Crap is going on. Right, too many spheres, clearly. Okay. But yeah, this is as if you had those guys. That doesn't feel right. It's probably the half spheres number being a bit wrong. We should be seeing more. We should be seeing like a full party going on. Like, those are those guys. We're seeing even less. This is the next one to sort out. But I guess when you change between these two, oh, you still see a difference. See, if you're seeing like it encoded on there, from far away, they seem to be offset in a weird way. I think. If we look at the position of some of this stuff, it does move, I think. It's hard to tell. It is really hard to tell because I don't know where they spawn new ones. Which one of the direct children? We can tell the renderer to only render the first child cluster of a node. And we should be able to play with that. Pair clusters. So when you go to select the children, right, you make this only do the first one. And then, voila. So it only pushes on one child. So one of these will have two children. There you go. Wait. That's not one child. It should be 2 by 2. Wait, each cluster can push one child down. The logic. What the crap? Why am I getting... Oh no, because it can have 64 spheres, can't it? Yeah. Right. So it's a 4 by 4 by 4 cluster. That's why. So this one looks like the lower left, but it's dropped. So there's definitely something wrong with the translation. Huh? Bit small, but there you go. So we can debug draw these clusters. Where's the size of the cluster? Probably, you know. Offset and local space, half dims. Half clustered in. Let's try these debug draws. It's lacking. I start building X grid system for game. Sweet. Nice. Is that 2D or are you doing it in 3D? Alright. So what are we looking at here? Is my LOD system effed? Here's that way, doesn't it? It appears like wait, so it's always putting a child down. Hang on a minute. Yeah. If it has children, it's gonna do its thing. If it has children, push one child on. And then get the bit set, take the first one and we'll break. So we're only doing one at the moment. But it's the one that it's been assigned. So that one doesn't have any spheres. Should have spheres, but it don't. This one has spheres. Oh no. That one does. And they seem to be kind of repeats. I think the parent and child indices are wrong. Yeah, I think the parent and child indices are a bit wrong. I don't know why though. So why don't we output their indices? And you output your parent. Cluster has parent that. So cluster instance dot volume dot cluster index, and then you want to have your parent. So that'd be cluster on node. I don't know what's it made out of. Parent cluster node index rolls off the tongue. So that one is there. Okay, so see what we get. We should probably only render one instance really, right? If we're doing all this. Printing stuff. So the printing is saying this one has parent that, yep. Parent 240, yes. Okay. That all seems fine. So what is up with the location, if anything? Let's put their position in space. Down. So the position in space is in local space. So what does this cluster start? Then you probably want to also have the size of the cluster. The half dim. Half cluster dim snorm. Well, it might be 3D graphics, but essentially 2D gameplay. Nice. Haven't started yet. Some different ideas. Cooking up in a project. And I use G-test to provide all kinds of different entry points. Cool. Reblob Games is a good blog. Oh, the rectangle cut thing? Yeah. Dead simple layouts, rect cut. What? No, the internet is dying. This is crazy. Quick download it. That's a shame. Wow, the internet is dying. Websites are disappearing. Yeah, let's just print this out. Let's load a bugger. Go to the parent node there. Right, so 0 by 1. Right, let me just see this in action again. So when we that's up there, then it goes down there. So that could be okay if it's like one sphere of this goes down there, if you will. But no. Then this one doesn't have any. What? How does this one have any, but then completely filled with spheres? I guess we're picking the first child. Is that a problem? Is that a problem? In this debugging thing, is that an issue? Yeah, it's as if you want to locate the child that that sphere is made for. And follow that. If we follow one that has spheres all the way down, maybe that's good enough. So perhaps you just say so wait, you need to get the child cluster node. So cluster, yeah, it's a child node, and we're going to say if it has spheres. So if child node dot spheres bit set, yep, 0 or 1. If that is if they're not of that, then we're going to continue. And I guess we might not always push a sphere on. No, we should do. Ah, shoot. No. Oh, we survived. That never usually happens. Alright, I'm glad I didn't take the whole stream down. But yeah, it's probably not inserting. It probably never inserts a cluster. Oh no, that's an infinite loop. Shoot. And let's take the bits off. That was the problem. Ooh. N normalize, N take NN. N cube. Ooh. We'll give you something that looks a bit like a sphere on spheres. So I just need to do that as many times as I have LODs. I wonder if there's... like... What? Why isn't that... Wait a minute. Can we fit another sphere up there? This is only meant to be a 4x4x4. Something's clearly off there. Like we fill that up with spheres. We can do that in the prepare sphere shader. Thank you, Rasmus. I'll check that in just a second. Thank you, appreciate it. We're going to remove this, and we're just going to make it always have a sphere there. So now they're going to be filled with spheres, the clusters. That's wrong. Yeah, we seem to be off. By some half size. Well, it depends, right? Yeah, because if you see this, change between these two. That sphere should have a 2x2 in it. This is way off. It's probably this code. Cluster lower left. Put position. Put position in the bottom left of sphere. Why? Why bottom left? Because this wants the center position. Dim at LOD, so that's the half dim. Yeah, it's off. So we need to then add. We need to add something. We need to add a half dim. So I think that could be maybe some of the problem with the offsets. And maybe that is part of the issue with the reason why the LEDs pop and look a bit bad. Well, it definitely doesn't help, right? Right, that's better now. I think. I don't know though. So if you look at that one, if you go down. Oh, not that one. If you look at this one, if you go down, it should be a 2x2 there. This should be a 2x2. So I guess so. What's up to about there to do that? There's something off with the size. Maybe that's alright. It's much better than it was, I can tell you that. So let's change this back now. So it's only going to do this one that has spheres. Yeah, I don't know what the children of this. Like it picks the first one with spheres, and I guess it's not one which, yeah. Just the way I've written the code to do this is not right. So that's the reason why it looks wrong. But the tree is correct. That's fine. So let's revert some of this code back. This needs to be like a count bits. Bit count. U32 of children bit set. I forgot. Git diff. Can't wait to try that thing you've put Rasmus Go. What? Yeah, right there. Bit count. Node.children bit set. Alright. We don't need to do the debug draw anymore, or the printing. Okay, so let's try Rosmusko's equation, if you will. Let's up this to 4 again. Alright, so we do that count sphere normal. Count sphere normal. So we're turning to spherical coordinates and all that, but Rosmusko is just saying if you simply do norm right, so n is normal. So you produce your normal. And then n, and then he said it's n, or normalize the result of n subtract and you got to square a square of a square. So let's try that out. Sorry. Oops. All right. And so this is the regular one. Now let's choose LOD 4. Maybe my thing's a bit wrong. Did I do that right? Yeah, so that'd be in world space. Correct. Did I do an extra square? Did I? No, you just multiplying the result. Is that right? Is it still wrong? Um, it should be one square and one multiply. Hmm. Same thing though, isn't it? Just multiplying with. Maybe. Isn't it the same thing though? Maybe. Maybe. Same thing, isn't it? Same result. Mol. Then multiply n times n, that's a square. And then multiply again. Yeah, it's the same. Well, you're definitely getting... Right, so we can change the LODs at least. I'm expecting to see a pinch here. Bit of a pinch. Because there's this sort of gap. Expecting some sort of pinch. But yeah, it doesn't seem right. Things off there. So for now, I'll just comment it out and we'll see. Maybe. Just go up close here again. See, this looks kind of right. Right, now we're seeing a 2 by 2. Yeah, so we're seeing them lined up a bit now. So let's try and find a 2 by 2, which is on the edge. Just study it. There's one there. That should be one. What the crap? Are these turning into not 2 by 2s? Oh, I've got a mostly full algorithm. That's why. Yeah, I got a mostly full. So if it's missing one, it will still turn it into a full one. Right. That's okay. Sure. So it's messing up the light though, because you're getting black here now. Shoot. Yeah, the light is definitely going all the way around like that though. And here. I guess you get it, right? It's kind of alright, but I think it needs to be a bit... It's close. The pinch is a bit too much. Also, why... So when you see it change? It does change. It is darker. That's the thing. That sort of pinch area is a bit too big. For some reason. So I think so this pinchy area here, it becomes a little bit too much of its sort of like we're getting too much of that or something. So maybe we if we multiply, if we make this window shorter, it should reduce the pinchiness, if you will. So if you scale back the scale by 0.75, maybe it's a bit too much, and then you scale back this quarter thing, maybe that makes it better. Not very correct though. It's a weird bug that keeps happening now. Right, so here you're getting a bit of pinchiness now. But you're not getting enough, maybe? I don't know. It's interesting. So do you see it? Zoom. Right, it's definitely less. You see the pop in less. Still see it though. But I wonder. Like that's a 32. Yeah, still see it kind of. I'm not sure how we could avoid this. Maybe it has to just be painfully part of the art style. Maybe. Or perhaps these are animating all of the time that you don't see it because there's always change happening in some smooth way or something. Something to think about. I don't know. Like ideally it'd be great to have these huge. Yeah, we've really messed up these LODs, I can tell you that. These LODs are messed up, they're wrong. Yeah, you see that come over just a little bit. It's still, would you say it's got dark? Feels like the side is very dark still. It's the side. That side part got, ugh. Why is that so dark? These aren't as bad. Like, what's up with these normals? So here you're getting that sort of nice. Maybe it's kind of right. Yeah, I've got to think about how I want to approach this problem because we might not be able to get rid of it, and it's kind of important. Um, because the problem with these spheres is you're gonna want to change the LOD so they're not as bad to render, but you don't want to make it so they're sub-pixel when you do it, because then you end up with the same sort of problem. You get all these funny looking like circles that appear, patterns that appear on your, so, and it's worse performance, right? So we want to make it so it selects the LODs earlier, or the lower level of details earlier, and when you move, we want to make that so you don't see it. Yeah, we really messed up these LODs. They're not good. But they're too dark, that is for sure. I don't know what we did to these boys. They got a lot of dark space. Huh. Yeah, the mapping is obviously a bit wrong. Probably this number of half spheres thing, it's going around the back of the sphere. So it is when you do an extended version, for crying out loud, my mouse pad, I was trying to draw a perfect circle. So when you do the next LOD up, it's got to have another two of these boys here. So you got two straight edge ones to remap. So when you do a quarter, what you're actually doing is against one of these. Yeah, one of these and one straight edge. So when you're remapping it, it's 3/4 round, remapping it to plus a half. But the half is mirrored back. So you mirror it. So if you land in this one, you're not mirrored. If you land in the next one, you're mirrored. If you landed in the one after, you're not mirrored. Mirrored. Um, so that's why you're getting so much black show up, because it ends up going around the back side of the circle, of the sphere. So it end up around the back here. So if you add another half, you're basically making normals for these guys, when really you should be making normals like that, and then like this, rather than carrying around the back, right? And so that means after the first quarter, it's first quarter, then it's a bunch of halves. And if you land in one of the halves, you need, so if your scale is in between, if your scale is on an odd half, basically. Then you flip it. Then you flip the yeah, it's on an odd half. You want to flip the final result. Or that's the X and the Y in that case. But you got like a Z now. Bit funny. Yeah. So I guess just to write the code for it. So it'd be something like if your final if you take away the just call that M or something. So if you take the scale, you take away the single. Yeah, that's the same as doing that, but it'd be negative. So then divide. So now you basically get like a 0, 1. You get 0, 1, 2 or whatever. Then you floor that. And with the floored result, you want to do something like you say if it's even. So cast it in. Yes, if it's odd, you flip. Sorry, if it's even you flip. But what do you flip? Wait a minute. You want to do that on a per axis basis, not with scale. With where do you end up? Yeah, so that's probably like an SY. And then something like I'm not sure how you'd flip what. So if you're Y, you want to flip the XY, but what about a Z? The Z axis would be the same, but across. Probably the ZY. So imagine the X is the Z. You would flip the Z and the Y probably. Then you get like a double flip. Maybe that's alright. So you basically want to say if Y. Oh, wait a minute. You've only got your spherical coordinates. So maybe you just flip that. I think that's the answer. Huh? What? Oh, SC, right. Of course. Okay, let's try this out. Sometimes it messes up now, it's not good. Oh shoot. What's up these damn... What do I get? I've got even less spheres. Don't know what I've done. Yeah, that maths is wrong. It's better near the top. But near the bottom, I'm not quite... Yeah, it's a bit off. But yeah, you ain't seeing it. Better, but still. Still seeing the pop in. Yeah, something wrong with the flipping. Yeah, oh well. Right, I think I'll just have a think about that. Trying to understand, so mapping the normals, we would see the lowest LOD on a quarter of the higher LOD. Would the absolute value work for the flip? Like the full bridge? Rectifier and electronics. I don't know what that means, but okay, it's interesting. Yeah, so we're just trying to... It's recursive. So the second highest LOD, which is this guy, is going to see... It takes the quarter... Wait, did I remove that flip thing? No, I didn't remove the flip. I kept the flip in. So I kept the sign. I did an ABS of the normal. So if it started off down here... Wait, down here, off this LOD. I flipped it so it's up here and done the remapping. And then flipped it back. Yeah, the multiplier. Yes, the basic idea is if you take a sphere that's the second highest level of detail, it's going to try and get the normals of the spheres that are the highest level of detail. That's the basic idea, right? But then if you have an even higher level of an even lower level of detail, it's going to try and get the normal for all of these spheres on the surface of its sphere, right? So it's going to try and make it look like as if this big sphere is all of these smaller spheres. That's the idea. That's the idea. But yeah, the maths was a bit difficult. But I think I got the first one fine. It's just the second and beyond. It's got to deal with these half spheres that end up flipping it back the other way. Actually, Yes. How many half spheres? This is flipped. Yeah, and then this is going to do another flip, isn't it? Wait. So rather than going all the way around, that's going to flip it and go there. That'd be an even number. But then it would just stop there because it just does 1/4. So it just does 1/4. And then this doesn't need to get flipped anymore. This one should get mapped to that one. Doesn't need to be flipped. But then it will flip this. Sorry, it'll flip this back to here. Do that. Flipped. Okay, why is it flipped? Yeah, so it doesn't go all the way back around there, but instead it gives you that, but then flips it down, yes. Then you flip it back again, which flips it up. Shoot. Okay, yeah, because you meant to flip that back to there. Ooh. Yeah, there's a double flip going on. Whoops. So these need to be... so based on whether the y sign or the x sign or something, but it's polar coordinates. Yeah, it's a bit of a bugger. I think I see what you're saying. What visual result are we expecting? Do you expect to see the exact same visual result forcing a higher lower LOD? Got lost. And what? I'm not sure about the computation cost. That's something to measure. There is a bunch of cosines and sines going on. That's a good point. Maybe it could be encoded into a texture. That's a way around it. I don't know. Yeah. I'm just trying to experiment to see, can I remove the pop-in? Right. I'm trying to figure out, is there a way to remove this pop-in that we're seeing when you move back? So I don't know. I'm just trying to see if when you reduce the level of detail, can we emulate having it looking like there's spheres there, but it isn't, because the normal is acting like there's spheres there, but it's, you can see there's a clear change. Yeah, it's still wrong. But yeah, I gotta have a think. Maybe there's some other ways we can solve this problem. But yeah, I'll think about it off stream. Anyways, it's getting kind of late now. Need to bail. Yes, I'm experimenting with a visual thing. I want to try and avoid the pop-in. That's the idea. I'm experimenting to see, can I visually make this look close to identical, if not identical, right? Where you don't see it. When you change the levels of detail. So as we get closer, it's changing, right? and further away. I don't... Maybe there's a way that we can animate it. So if we animate it, maybe it doesn't register as much. I don't know. Or maybe the pop-in is just... No worries, no worries. Maybe the pop-in is something we're gonna have to live with, so we just make it part of the style in some way where it doesn't feel janky, right? Yeah, I've got to have a think about it. Because this is a big issue, right? Well, it's an issue we'd need to settle on in some way. But yeah, I'll think about it. Alright, let's find somebody to raid. So our next Beyond on Tuesday at 7:30 GMT +1. But yeah, thank you all for coming, everybody. Right, I might bail. I gotta go ASAP.